Well, I see it's 8 o'clock, so I think we'll start our workshop up. Welcome. My name is Leif Hauge. I'm a senior civil engineer at Waukesha County's Land Resources Division, where I've been helping run this workshop for the last 20 plus years. I presume pretty much everybody except perhaps a couple presenters were tuned in yesterday, so I won't go through the housekeeping stuff again, other than to reiterate that after the workshop, you'll get an email from Wisconsin Land and Water, and it'll be about an evaluation poll that we'd like people to turn in. And then after people have completed the workshop evaluation, they'll get a PDH certificate for the hours that were clocked as having been attended. After the workshop, Wisconsin Land and Water, as part of that, will also send a notice about posting recordings of the workshop. So for our first speaker, we have Paul McGinley. Paul's a professor emeritus at the University of Wisconsin-Stevens Point. He previously taught water resources courses in the College of Natural Resources and outreach courses in water quality and water resource modeling. His current research focuses on improving water quality in natural and engineered systems through field experiments and the application of simulation models. And Paul is going to talk about a shoreline phosphorus calculator design tool that he developed. And Paul, I'm especially interested in this because for about the last 7 or 8 years, shoreline zoning has been requiring people that exceed a certain percent imperviousness on their lots to mitigate that by putting in practices like rain gardens, permeable pavement, and infiltration trenches. And so I'd like to know if what we're doing is doing any good. So I'm hoping that some of your presentation will address that.
All right. Well, thank you, Leif, and I really appreciate the chance to join the group today. It's interesting you mentioned the importance to county activities. We actually started this project just a couple of weeks before the pandemic. It was at the Wisconsin Land and Water Conference, over that'd be early 2020. Getting together with a small group that was very interested in just coming up with some tool that we could use to try to estimate how much phosphorus we're getting from at an individual lot level on a shoreline. And it's a kind of a classic stormwater modeling problem, I guess, in a way, but also has some differences. And what I'd like to do is just go through a presentation that talks a little bit about our strategy for developing this. And of course, I've got to start, and other speakers yesterday mentioned, talked about phosphorus. I won't spend a lot of time on it here, but when we think about our inland lakes in Wisconsin, a lot of that biological productivity can really be limited and then subsequently driven by additional phosphorus loads. So phosphorus is a topic that a lot of lake owners, lakeshore landowners, and water managers are acutely interested in. So we wanted to focus on a tool that talks specifically about phosphorus, and we also wanted to connect it with an ongoing effort in Wisconsin focused on stormwater management at the lot scale in this Healthy Lakes and Rivers program. So this is a program. This is actually a website here that's sponsored by the DNR and University of Wisconsin Extension that talks about practices that lakeshore landowners can use to manage stormwater runoff. There's a grant program associated with this, and so the target here, the target audience on this would be lakeshore owners, organizations, county level organizations, lake level organizations that are interested in trying to evaluate the impacts of stormwater on the shore, from the shore on the lake, and then also how the changes that they can make to that would benefit the lake. So really looking for a quantification tool that we can apply at the lake lot level, which means it has to be relative. I mean, nothing is simple about this, but a tool that is relatively simple to use. And so that kind of drove some of the direction that we took with this. It is a bit of a work in progress, so I'm really excited to join this group. And if you have comments, follow up, I've got contact information at the end. I'm really looking forward to some additional feedback on the approach we're taking and the direction we're going. I should acknowledge some of the collaborators here. So Dave Ferris was a county conservationist in Burnett County in Northwest Wisconsin, and really driving the desire to get this done. And then we also had a small group that we met quite a bit during the pandemic. Cheryl Clemens with Harmony Environmental, Carolyn Shaw with Vilas County, and then Emily Moore and Sean O'Connell also with Burnett County. And we did get comments from others as we've been trying to push this out over the last couple of years. All right, so what I want to do in the next 15 minutes or so, talk a little bit about shorelands and phosphorus. I mean, set up a little bit of what we already know, and that's kind of some of the unique features and some of the more general features of thinking about shorelands and phosphorus and lakes. Talk a little bit about the model development, the approach that we took, why we took that approach, and then go through a brief example, because by the time we get to the end of this, we've tried to distill this rather challenging modeling exercise into a spreadsheet that we think is somewhat easy to use. All right, well, I think we can all envision the scenario here, but it is amazing when you look at the plan view of lakes and the parcels and the development along lake shores. I mean, it really is um, quite a bit of what we would think of maybe as runoff generating areas of impervious surface, areas of disturbed pervious, and all very close to the water. And generally those areas are uphill from the lake, of course, because the water, of course, is going to run downhill. So we've got this scenario playing out on lakes all over Wisconsin. And it's a challenging modeling situation because you're really looking at impervious surfaces at some distance, or runoff generating areas typically at some distance, although not a great distance from the lake. And so we've got the passage of runoff generated from those areas over areas that do have the potential to do some mitigation, right? You get some infiltration possibilities in that pathway. Well, it's a subject that's been of interest for a long time. Were studies in the 80s, there were studies in the 90s, reports in the 90s. This is just one example where an early DNR report it looks like there's evidence here that the phosphorus generated, and there's of course a lot of phosphorus on land, and we've got the capacity here, the ability to move that phosphorus downhill to the lake, that this development could pose a threat to lakes, and that you're moving additional phosphorus from land to water above, say, that baseline or a desired level. And there was a study about 20 years ago, almost 25 years ago, at several lakes in northern Wisconsin, put together by Wisconsin DNR and USGS, and really a nice report. They instrumented sites adjacent to homes, in woods, on lawns that were right next to the lake, and then measured flow, measured phosphorus concentrations, calculated phosphorus loads from these small scale experiments, if you will, or lots, and tried to quantify, all right, what's the amount of runoff that we're generating? What's the amount of phosphorus that's coming out? What are those concentrations? How does that compare between different areas around the lake? And one of the observations, and of course, not going to be a surprise to us, but the quantity of phosphorus, it was pretty clear the quantity of phosphorus transported is pretty strongly related to the volume of runoff. Certainly the concentration would vary at these different sites, so it could vary maybe over a order of magnitude, maybe a little bit less. But the runoff volume would vary over many orders of magnitude. So when we're thinking about the actual mass of phosphorus that's, say, being transported along the shore, it's really strongly driven by the volume of runoff. Well, we're trying to reduce, and in our case, we're trying to reduce and create kind of a simple tool. So this really directed us to kind of focus on runoff volume as a primary thing to describe, and then think about ways that we can account, turn that into a phosphorus load and talk about concentration. We'll talk about that in a minute. But going back then to the kind of the fundamentals, right? When we're talking about a shoreline zone, we are really talking about a classic stormwater problem, and that's the disconnected impervious, the impervious or runoff generating areas that are separated from the discharge point by some area that has some infiltration capacity or some ability to mitigate runoff volume, as opposed to, what often drives a lot of the more urban scenario, which is, that runoff that's directly connected to some sort of outlet structure or pathway. Now, this has certainly been a research topic, and we got into it a little bit. This was an experiment that one of our grad students at UW-Stevens Point, Kaylee Foster, did about 15 years ago, instrumenting, creating kind of a simulated downspout and instrumenting some channels around the different lakes, and looking at, okay, how does that, right, the classic disconnection problem, how does that runoff volume that's generated uphill moving across a pervious area, how is that mitigated? How is that infiltrated? And it's not a small research area. There's a lot of research available on this topic. And so what we tried to do in our work was, okay, let's try to synthesize this. Let's try to turn this into sort of a simple modeling tool that we can use around lakes. And we focused quite a bit on a couple of these studies. I will highlight Anita Thompson's and Greg Miller's study here at UW-Madison, looking at infiltration of stormwater runoff on urban lawns. Well, we have to be humble, I think, when we're talking about stormwater disconnection, because this is a pretty complicated area. I know that Richard showed this a portion of this slide yesterday, but our goal here was to try to make something simple enough where it's going to be useful. But we certainly know we're making a lot of assumptions, and hopefully we're not oversimplifying this problem. Okay, so thinking then, how do we tackle this? Well, we've got the shoreline zone, we've got the runoff generating areas, we've got some kind of pathway to the lake. Our simple description of this then focuses on volume reduction as our treatment. So essentially, we're going to try to describe how much runoff is generated from the runoff generating areas, and then how much of that I lose either through the installation of some kind of practices or through that disconnection process, right? That ability of the pervious areas between the runoff generating areas and the lake to actually reduce that volume. So part of the goal here is to provide a realistic description, and to do that, we felt it was necessary to accommodate in some way what everyone can clearly see around a lake, and that is, okay, in some areas I'm going to generate more runoff than others, but I'm also going to, depending on the conditions between that runoff generating area and the lake, I'm going to actually infiltrate more or less depending on the conditions that I have on that particular lot. Okay, so the approach then, and this will look, of course, a pretty classic stormwater modeling exercise, right, is that we would have some type of runoff generating area here shown as an impervious surface, the potential to put some sort of a practice in there. And as I mentioned, the healthy lake practices include rain gardens and infiltration trenches. So we've got that ability, sort of classic stormwater modeling, I think, runoff generation, low impact development practices, then try to find some way to accommodate that disconnection. And so I'll talk a little bit more about that in a minute, but trying to find a simple way to describe the ability of that background system, or the existing lot system, to provide some reduction in the runoff volume, and then to try to accommodate a potential for some sort of buffer. And again, simplified here, our focus was on infiltration, and so our attempt to provide at least something related to the buffer was related to the ability that, okay, that may spread out the flow, that will hopefully provide a higher infiltration rate, And so just making a modest adjustment for the fact that, okay, if I've got some very high quality area near the lake, then I'm going to essentially give some credit for that. The focus here was on volume. So we're going to create or try to figure out what's the runoff volume generated in this case. And then rather than get into the details on concentration, let's just assume a phosphorus concentration. So in our case, we're assuming a 0.5 milligram per liter is the phosphorus concentration. Again, right, looking at the previous studies, particularly that USGS study, a lot of that was between 0.3 and 3. Right, so we're not on the high end of that range, but we're just trying to find, kind of a reasonable value to turn that runoff volume into a phosphorus load. All right, well, we got to think about how we're going to model this. And of course, Wisconsin has an approach in our stormwater management of using continuous simulation models to describe this, right? It's a classic example where I've got runoff generating areas. I can simulate a group of storms through that. I can simulate the behavior of a mitigation practice, and then I can try to figure out how I'm going to accommodate that disconnection in that model. Well, what we did was, in terms of that disconnection part, this part maybe being relatively classic up here, runoff generation, low impact development practice, did something pretty simple. And that is based on the previous literature. We said, all right, let's just create this standard disconnection zone as an area where we specify a geometry of an infiltration area. So a width of that length here is adjustable. That's right, the distance to the lake. The 40 and the 35 here create a 75-foot distance, which is kind of a standard setback distance in Wisconsin for structures from a lake. But it's not always that far. And so then we wanted to make sure that you could shorten that if that was appropriate in that situation. So that length is specified. And then we just varied the width based on some of that previous research based on slope. So nothing particularly complicated here, but sort of an average slope around 5 feet wide, very flat slope around 10 feet wide, very steep slope around 2.5 feet wide. So again, and Pete talked a little bit about this yesterday in his presentation, that these details matter when we're talking about moving something along a pervious swale, or in this case, we're viewing this as a setback zone along the lake. Those are the assumptions we made, and again, right, that everything has to be interpreted in that light. We also have infiltration in there, so we're looking for some type of an infiltration rate, and that gets into one other thing that was referred to yesterday. The challenges of trying to figure out an infiltration rate in a potentially disturbed residential environment. And so in this case, right, part of the educational effort is, okay, you got to pick an infiltration rate. We often maybe assume that's based on texture, but here we might also want to be certainly accommodating texture plus disturbance. And so driving probably the assumed infiltration rate a little bit lower than we would have, if there's some level of disturbance out there. All right, we're going to come back a little bit to that in a minute here. All right, so how did we approach this modeling wise? Well, we ended up using, and not that we need another stormwater model in Wisconsin, but just for convenience, and this is quite similar, I would say, to the existing modeling infrastructure we have in the state, in that we use the EPA SWIM model. And the reason we use this is it's quite similar to the other models. And in fact, we adapted it in a way that by using Wisconsin's hourly rainfall files from the DNR website. So we adapted those to this model. The advantage for us was that this could be automated with Python packages. So we can set up a base case in this model and then run it thousands of times and use that to populate the spreadsheet that we use that essentially become just drop downs for ease of use. All right, so some of you are probably familiar with this one model, but maybe especially on the hydraulics side, but it does have some pretty user-friendly hydrology applications, and the graphical user interface. You can drop kind of subcatchments is the term they use, or little water, little runoff contributing areas and infiltration areas. And so our intent here was that no one would have to use this model, that we would be running the model and then providing the information, and then people can access those results. On the other hand, we did want to have a little upward compatibility, if you will. So if somebody wanted to try something out different, or we didn't have everything in our many simulations that they could actually use, that they could actually go back and run the model. So we do provide a little bit of information on that. And so then we basically then are just taking the runoff situation that we talked about, impervious surface or runoff generating area of some kind, some type of management practice, if included, rain garden, infiltration trench, making some assumptions about the geometry here. And we'll talk a little bit more about that. And then some characteristics, variable characteristics of this setback distance. By the time you put in, say, 7 or 8 different low impact development scenarios, 3 different infiltration rates, 3 different slope possibilities, 3 different infiltration or impervious surface sizes, suddenly you get thousands of possibilities. And so set up the model to run, even just with one precipitation file, you're up to something like 3,000 simulations. Each one takes, depending on your machine, a minute or two. And so you run the thousands of simulations, and then we can summarize the results. So how did we summarize the results? We took them and basically put them into a Excel spreadsheet. So now we've got thousands of lines here, each line representing an individual simulation with some range of those conditions. So we've had to pick those, right? They're discrete values inside those ranges. And then through a match and different formula, and a simple formula in Excel. So it's just a formula up here that relates to this calculation. And you pick all the drop downs, and I'll show in a little bit more larger example in a minute. Picking the different values for the different conditions on the lot, then it'll seek the solution in that worksheet that has all of the solutions in it, and then out would show the results here for an average year and the maximum year. And again, as I mentioned, we're using the hourly rainfall files that we use, say I guess the P8 files, which you might think of them as the P8 files. So these are hourly rainfall files. In this case, this spreadsheet here uses the Duluth file, so that's 1960 to 1995. So it's running the 36 years of those rainfall files, giving us the average year and then the maximum year in those 36 years. That spreadsheet, if you're interested in exploring that, just email me and I'll email you the latest spreadsheet. We also created a sort of a preliminary website where we also have the manual, which I'll talk about in a minute, and the background information. So on that website, and I'm happy to also email this to you, we have just a 12-page report that talks about this approach that we used and some of the rationale for the decisions that we made. And then there's a much larger appendices, which shows all of the results in table form, even though they all show up in the spreadsheet for these base cases that we experimented with. And then it also has some information on a little bit of background on the simplified version of the model that we use using the SWIM model. It does have the text file. A SWIM simulation operates off a single text file, and in addition to the precipitation and temperature files, but it has a text file that you can just copy and paste this into SWIM and then bring that in as an input file or INP file into SWIM, and you could run the base case model that we're running. That also shows all the assumptions that we made. They're also detailed in a table in that report. As I mentioned, we did use the rainfall files and the temperature files. Again, that meant that we didn't have to develop a whole new set of rainfall files. So it was quite convenient to actually use the existing rainfall files. On that web page that we're kind of working on, the results are also presented in another form, and that's a table where you can actually just adjust the slope and the impervious and the setback and the infiltration rate for rain gardens, infiltration trench and buffer, and actually get and again, it's the same thing. It's just tapping into that tabular 3,000 solutions from the range of conditions that we put in there. Again, a person could run the program by putting their own in. It's just that this gets us to that, trying to make something user-friendly for an audience that might not really want to get into modeling. Okay, let me wrap up with just a couple of slides at the end here. So here's an example of that spreadsheet that I was talking about. So drop downs for all of these categories: impervious surface, treatment practice, infiltration rate, slope, setback distance, and buffer. Pick those, and out would pop a phosphorus load in pounds per year. In this case, the infiltration rate is pretty important, right? You get sandy, undeveloped, undisturbed soils. You're going to have a pretty low predicted phosphorus transfer rate. If it's much lower infiltration, that's going to be, 10 times higher. Then, what is a particular interest here for, thinking about our audience, right? We've got shoreline owners, groups interested in putting in stormwater management practices. They're interested in, okay, what if I put in a rain garden? What if I do an infiltration trench? We had to make some assumptions here, and that's detailed, right? 8-inch deep rain garden, 24-inch deep trench. But for those particular conditions, you can pick a rain garden or trench, put that in there, and then here, adding a rain garden, 200 square feet to our 2,000 square foot impervious surface. Looking, okay, I'm getting some phosphorus reductions here of around 50–60%. Okay, let me just close with two quick slides here. So again, just an attempt here to come up with a relatively simple tool, partly education, partly quantification, to try to help people understand, all right, if I'm going to start to manage my manage stormwater runoff at the lot scale, what sort of benefits can I actually realize? It's not a worst case scenario here, right? 0.5 milligram per liter phosphorus. We are not talking about, massive, quantities of sediment moving down slope. We're, again, referring back to Pete's comments yesterday, we're talking about high quality disconnection areas here. And just trying to provide a little bit of credit for that. Sometimes the numbers look pretty low when you're on a lot scale, but of course, going back to the fundamentals of phosphorus, the goal really should be zero, right? We do not want surface runoff entering a lake. That's not how we want the water to get into the lake. All right, what's next? We're continuing to see comments on this. I look forward to hearing from many of you with your observations or thoughts on this, and we'll continue to revise and improve and look for ways to apply some research to help understand the things that we weren't able to describe quite so well in the model. All right. With that, I think I've used up my time, Leif, and I will turn it back to you.
Yeah, thank you.
All right, thanks.
One question I would have is, it looked like the model takes into account antecedent soil moisture conditions. Is that correct?
Yeah, it's a continuous simulation model that does do some moisture tracking and evaporation. So nothing particularly complicated there, but there is it's not using a I'm thinking specifically here on the disconnection portion. It's not a uniform infiltration rate. There would also be some sorptivity, if you will, or some higher infiltration at drier, if it's tracking the soil as being drier. So yes, to some extent, there's a little bit of accommodation for that.
Okay. Got one question. Can you determine the infiltration volume from the model?
Yeah, I mean, that's not, yeah, in fact, I guess we don't show that on the spreadsheet, but that is an output of the model. So if it would be useful to track exactly what that fraction of the runoff was that infiltrated, to some extent, it's a little bit proportional here because we're just assuming a uniform phosphorus concentration anyway. So if you have a 50% reduction in phosphorus, you're basically having a 50% reduction in runoff volume. So, just because we and again, right, this one of our goals was to make it fairly transparent. So that's, that's not a complicated way of looking at this, but yes, I would, the in our case, in this model's case, any reduction in phosphorus is really a reduction in runoff volume.
So a runoff volume reduction is not an output that's stated, but it can be back calculated from the other outputs.
Yeah, and it really and I'll take that as a good comment or as a good suggestion. That would be very easy for us to add, say, to the spreadsheet because that is actually something that shows up in the table solutions, right?
Yeah.
That's the spreadsheet actually calculates the phosphorus from the runoff volume. So
I
we
think
could put some.
for at least some like regulators like myself, that would be irrelevant. It's something that we would probably like to know because one of the stated things that people have to do is reduce their discharge by a certain volume. But we tend to do it on, we just go by the half-inch rainstorm. Say you have to calculate what that volume is and then design your rain garden or trench accordingly. But you're looking at it in a, well, I think you said a 35-year window. So that's in some ways a lot better, obviously.
Yeah, right. We were interested in that average annual. Just, and again, I didn't really focus on this part, but another application is people thinking about a phosphorus budget for a lake, right? So we do spend a fair amount of time trying to account for inputs of phosphorus, and this might be a way to try to quantify a little bit better. We hope, again, not worst case, hopefully average annual, of how much phosphorus is actually moving from the shore into the lake.
Well, thank you, Paul. That was really interesting.
All right, thank you.
Next presenter we have up is Kevin Hopkins. Kevin's a project engineer working with Aquilus. He earned his BS in Civil and Environmental Engineering from the University of Wisconsin-Milwaukee in 2021, where he held leadership roles within the volunteer organization Engineers Without Borders and developed a passion for environmentally sustainable design. Kevin's going to talk about lessons learned from MS4 BMP recertification inspections. Just out of curiosity, Kevin, when you were with Engineers Without Borders, what kind of projects did you work on?
Our chapter does gravity-fed water distribution systems in the Achille Triangle of Guatemala. So those are the highland mountains there, working with indigenous communities. So we do annual trips building these water systems, and we're currently in the middle of a fundraiser, the Run for Water at the end of Milwaukee, uh, since he gave me a moment to talk about it. But yeah, so we do projects once a year. It's a great opportunity for students to get hands-on experience working with engineering design and the communities and learning about all the different stakeholders that go into these projects.
Cool. Well, I'm gonna disappear here and I'll pop back up when you got about 3 minutes or so left.
Sounds good to me. I'll share my screen and get started. Alrighty. Well, hello everyone. As Leif mentioned, my name is Kevin Hopkins. I'm a civil engineer working with Aqualis, and I'll be speaking with you all this morning about lessons learned from MS4 BMP recertification inspections. The format of my presentation will start with the why we perform these inspections. I'll move into how we perform the inspections and then dive into those lessons learned. So with that said, let's begin. So stormwater management, inspection, maintenance, and reporting. Before getting into it and going through our process, we should talk about what this document on the screen is here. So this is a cover page of a stormwater management plan for the city of Milwaukee. The one I have on the screen is a few years old, but they still look pretty similar today. What this document is an agreement between the property owner and the municipality that describes different stormwater BMPs a site has and different maintenance frequency schedules. So to get into what we do while we're on the site, so we're trying to document the current condition of the site. We want to verify that the site's drainage facilities are functioning as designed. So what that means to us when we're on the site is we're verifying the storage volumes and the BMPs match what the design was. We're checking the conveyance network and that it's functioning in a way that the water quality is being maintained. If not, we're going to at least note for maintenance and repair items to be completed by the property owner. And as I mentioned a moment ago, the stormwater management plan on the screen is for the city of Milwaukee. Depending on the community you're in, there'll be varying requirements, different programs. A few different programs that we've come across include these here: the Stormwater Management Plan Recertification, Stormwater Management Permit Annual Maintenance Certification, and the Stormwater Management Practice Maintenance Agreement Inspection. So why are these inspections required? Uh, Looking at it from a high level, a national or state permitting authority will issue a MS4 to a community. This MS4 permit will require post-construction stormwater management ordinances. If you're curious, the EPA or another state agency will have a model ordinance on their website. But basically, these ordinances will require maintenance agreements and inspection reporting guidelines that the municipality has to report on, and the ordinance encourages the property owners to comply. So the goal of all this is just to reduce discharge from pollutants entering the storm sewer system through long-term accountability. And an additional benefit is that landowners can benefit in the form of increased property value if they're maintaining their BMPs with their regular maintenance and inspection cycles. So when is the right time to act? So most MS4 permittees require an inspection at least once per permit term. So that's once every 5 years. There are some municipalities that require annual reporting of inspection and maintenance documents. This isn't a requirement in a lot of communities, but the EPA does recommend annual inspections at a minimum frequency. And in our office, we have found greater success from clients who do these annual inspections. We're able to catch issues before they become larger headaches. So if you're a municipality, you might be sending a notice to the landowner alerting them that an inspection or maintenance is required. And then there are also some municipalities that keep public record of these maintenance and inspection documents, as well as the stormwater management plans and any permits and agreements they have with the property owner. Moving into the landowner's point of view, so landowners can be sent notices from their municipality stating that they need to perform an inspection. The document we have on the screen here is from the village of Mukwonago, and was sent to a property owner at the beginning of January, and asked for the property owner to send their inspection and maintenance documents from the previous year within 14 days of receiving this letter. So this is one method that some municipalities go through to obtain the information. For this example, the property owner would have had to be on top of their maintenance. They would have had to know what they had to do. And then when Ron from Mukwonago reached out, they had about 2 weeks to provide that information. Let's see this next notice here from the village of Heartland. So this one set up a little bit differently. So they sent this one out in March and required their inspection and maintenance documentation to be sent over no later than the beginning of August. So they gave them a few months to perform those activities and then report back to the Director of Public Works. So those are just a few different styles of memos that we have seen on the inspection end. And attached to a lot of these notices are sample inspection forms that the community would like you to use while you're on site, or at least fill out prior to your submittal to them. The Village of Heartland provided this 3-page stormwater pond inspection for this particular BMP. There are fillable fields that you'd bring this form out with you in the field to make sure that you're able to collect all this information. So from there, once the property owner receives this notice, if it's like the one for the Village of Heartland where they'd have a few months to perform the work, the property owner will reach out to a licensed inspector or professional engineer to get that job done. So now moving out of the background information into what the inspections look like for us while we're and so we start in the office like most things. We get all the contracts signed and all that jazz, and then the inspector will be assigned to the job. And uh, first things first, we want to obtain any site-specific information from the client or the municipality. The document we're looking here on the screen is page 4 from that same stormwater management plan we looked at earlier in this presentation. Item 14 here in the middle goes through different structural and non-structural BMPs that we would want to keep in, or we would want to be inspecting while we're on the site. This particular site had catch basins, detention ponds, the outlet structures for the pond. Their non-structural BMPs included parking lot sweeping, recycling, covering their waste bins, carpooling, and litter elimination awareness training. So, you know, while we're on site, we inspect the things we can. There was only one employee on the site, so we didn't ask if they carpooled with anyone. But we want to make sure we're going through this document before we're going out to the site to make sure we know what is required to be done per the agreement. So, in addition to this document, we want to make sure we at least try to obtain a plan set, any aerial imagery or topographic maps of the site. And then once we have all that documentation, we perform our desk review and we create an inspection plan. And so a desk review can particularly be beneficial when there's not a lot of information provided for the site. We might only have an aerial image with a topographic map and the stormwater management plan with no plan set. So trying to piecemeal all the data together so we have a plan when we're going out to the site has proven useful for us. Uh, Creating your inspection plan will also make sure that you have all your correct inspection equipment because depending on your site, there will be different equipment needed. One site might only require a pickaxe and a measuring rod, but if you're going out and doing a pond measure down, you might need to bring a kayak if it's a nice day, or if you're going out and doing it in the middle of winter, you might need to bring something they'll let you cut down through the ice. After the inspection plan is created, the inspector will share their plan with someone from the office for safety reasons. We just want to make sure that somebody from the office always knows what the inspector is doing, uh, just for safety. I think that one's pretty self-explanatory. Don't need to get too into that. So uh, now that we have or that we're moving on to the typical inspection process from the field perspective. So before we get out to the site, we want to make sure that we communicate with the client that we are going to be coming to the site. We want to make sure it's at a good time and that they know that we'll be going there. So once that's done, once we get to the site, we still want to check in with the client. Uh, we've had a few situations where one manager was alerted, but the other wasn't. So we'd have an employee come out, ask us what we were doing. So we don't want to cause any concern with any employees at the sites that we're working on. So go and check in with them, make sure they know why you're there, and you shouldn't have any issues. But after you check in, you'll be conducting your field inspection. You'll be noting any observation you see regarding the site and its BMPs, and you'll be taking plenty of photos. You want to make sure you have your proper PPE, so your gloves, your high-vis vest or other clothing, your safety shoes. You want to have your inspection equipment, your measuring rod, your pickaxe. If you need any sunscreen or bug spray or protective eyewear, make sure you have that too. And then uh, once you complete the inspection, you'll return to the office, compile your notes, create an inspection memo with your photo log and a marked up site plan. From there, you distribute the memo to the client and the municipality if there's no maintenance needed. If there is maintenance needed, we include that in our memo, communicate that with the client, and then we reach out to our internal maintenance team at Aqualis to provide a quote to the property owner just to get them started on any required maintenance to save them a little bit of time if they don't have anyone scoped to do the work. So I know I kind of buzzed through what the field inspection looked like. So now we'll just take a moment to look at what we actually inspect while we're on the site. So answer that it's various BMPs. Um, is it a dry? Is it a wet pond? Is it bioswale, rain garden, permeable or porous pavement systems, underground cisterns, green roofs? We'll also inspect any riprap or cobbled channels that are on site conveying stormwater. We'll look into catch basins and other storm structures. We're also inspecting your general site condition, looking for any litter or erosion, looking for anywhere water's flowing where we don't think it was based on the design. And we're also checking for any illegal or illicit discharges. And again, depending on the community you're in, there might be an additional form to fill out to verify there's no illicit discharge. The City of Milwaukee has this IDDE form to fill out, and there are a few other forms to fill out around the state. So let's talk about some inspection observations that we've run into. Some of these are common, some are uncommon. They're in no particular order, so bear with me as we move through this list. First and foremost, riprap channels are washed out. We see this quite a bit. The photo we have on the screen here is a riprap channel at the edge of or riprap pad at the edge of a curb cut at a parking lot. So on the adjacent pavement to the riprap, you could see sediment accumulation. Uh, you could see the riprap stones are not very plentiful. You could see a pathway where the water is likely traveled and washed the stone away. So um, this channel has seen better days. You could see the the dirty runoff water path travel into this depression. Um, so with this observation, we would call out to have this pad refresh. It seems like it's done its job, and we could retire this one and get some new stones in there. Some other things we see include accumulated sediment in catch basins and sediment in pond bottoms. We also see site litter and erosion quite a bit. Uh, we have lids stuck on their structures, either due to paving or just other general conditions. Um, this photo here, I know you could see the lid quite well, but the surface was recently redone and some of the asphalt made its way into the ports where we were trying to get our pickaxe in and open the lid, and we were unable to. So you run into this every now and then. More often than not, it might just be a car or something else obstructing the structure, so you can't open it. We've also run into situations where paver areas have not been draining well. Uh, there's been subgrade failure in paver areas. That one's been a little more uncommon. We do run into wildlife quite a bit, whether it's a goose, a raccoon, or a beaver. Here's an example of a little raccoon that was in a manhole on a cold winter day, looking for some shelter from the outside weather. We also see animal burrows or dens in the side slopes of ponds quite a bit. A lot of the time, there's overgrown vegetation surrounding BMPs or accumulated sediment that has overgrown an inlet. Every now and then, there's a unlocked gate to a BMP, like a pond, and again, this is a public safety issue that we'd like to mitigate any risk there. A definite uncommon one we run into is a BMP has been demolished when we've gone to the site. So this particular example, we had an inspector travel from Wisconsin to North Carolina to perform an inspection. We reviewed the permit documents and a plan set. We thought we were good to go, and when we got out there, nothing was ever built. The BMP wasn't constructed, so the property owner or the property management company, they were paying this permit fee for a BMP that was not existing, and they got to pay us for our time spent performing that inspection and the travel. So that was a rather uncommon one we ran into. There's also pipe or just flared end wall section separation that we run into from time to time, and then trench drains that are full of debris, like you could see here in this photo. Um, Final part of the inspection process, like I mentioned, is writing and preparing this inspection memorandum. Um, All of ours kind of start the same. We're addressing who it's going to, who it's from, what the date and subject are. We note the weather during the inspection and the date of the last rainfall, including the depth of the precipitation. And getting into the memo, we list the inspection observations we made while we were on site. And then we get into any required or recommended maintenance items. We differentiate between the required and recommended maintenance items based on the site's maintenance agreement. So this would be that uh, stormwater management plan we've been looking at, making sure that are, if we're recertifying the site saying, yes, it is functioning per design, that they are performing every maintenance item to get it back to that state. Recommended maintenance items could be things that we suspect might cause them a headache in the next year or two, or even a little further down the road. And it could be good to handle the issue while they have a crew on site. After we finish writing the memo, we'll include a photo log, a marked up site plan, and any other relevant attachment. Relevant attachment might be a DNR form indicating good maintenance practice for their pond or bioswale. Uh, this diagram I pulled up is a marked up site plan that we produced for one of our inspections, noting where sediment was accumulated, calling out which each bioswale was called, naming each porous pavement area. So the inspection memo made sense to perhaps uh, the end user, which could be the maintenance staff, could be the property owner. Um, so that's why we include this document. Alrighty, so we made it through the background, the inspection process. Now let's get into these lessons learned. So first and foremost, having a desk review performed will more often than not lead to a smoother inspection. Just being prepared in general, right? It'll let you know what you're getting yourself into, and it will lead to a smoother inspection. Even in the case when you get to the site and the BMP is not there, you don't need to panic because you know what is supposed to be there per the plan, and you could see it's not. So you make your notes, and then you move on to the next step. We've also found by having records of previous inspections, we've been able to streamline our inspection process a little bit more and have more consistent results. We have a handful of clients that we perform annual inspections for, some even or 2 inspections per year. And so with these sites, we've had a lot of cases where there's no no required maintenance before uh, or after the inspection, and their sites stay in good condition because the property owner knows what the site's supposed to be looking like, and they call us out to make sure it's that they're complying. Um, Touching on that last note of having records of the previous site inspections. So we've been using GIS to manage our data more efficiently and to perform our inspections. So this has been really helpful for our field staff to be able to pull up photos on the site of what this BMP looked like last year to see how it's progressed, and to note if any changes or if any maintenance needs to be done with it if they were on the fence. We've also learned to work with caution when you're out in the field. The grates for these manholes are heavy. If they're rectangular or square ones, they can fall into the structure and they will be difficult to remove. And so just work with caution, make sure you have your PPE. Um, Clients also like to know what's happening on their site. So we have had multiple instances where a property owner would walk with us for the duration of the inspection, trying to get inside our heads, knowing what we are looking for so they can keep their site in good order so they don't have to pay large maintenance fees if they let their site go. Next note here is how inspections are how we can prevent stormwater related disasters. This inspection that we performed, or this photo here from an inspection, the flared end section for the inlet to the pond, was completely washed away. There was a ton of erosion around this pipe, and the pond was in bad condition. And this pond was located next to a railroad track, so who knows, if this pond was forgotten about for years and years, and the erosion kept going, maybe that the train track would have suffered some structural failures. But so this is what it uh, after the restoration efforts occur. This is what the that previous photo looked like. The next note here on the lessons learned is that municipalities and other agencies are pretty cooperative to work with, whether you need a plan set, a copy of your agreement, just reach out. If you need an extension, it's a human on the other end of that phone or email. So plead your case. You usually have some good luck. And then you also want to design with maintenance in mind. So to touch on that note of designing with maintenance in mind, so a few of these lessons are also from construction inspection observations we've made. So when you're detailing your cobble channels, you want to make sure that the inlet or that the top of the cobbles are detailed to be below the top of the adjacent pavement. In this situation here, if this wasn't caught before the project was finished and the cobbles remained where they were, there'd be an awful lot of pooling going on at the base of the cobbles. Sediment wouldn't be able to travel down into the basin. It would look unsightly. There would be some erosion as water would pool up, find its own path around the cobbles. So you want to make sure your details are clear, that the top of your channel should be lower than the adjacent pavement. This photo here shows what a properly designed and a well-maintained cobble channel will look like. There's no evidence of pooled water or sediment accumulation on the curb, uh, and the cobbles are at or just below that curb line. You also want to be aware of the proximity of your BMP to your surroundings. Um, Basically, you're just trying to make your BMP accessible for any maintenance staff. It could be a good idea to put a BMP in between two lanes of traffic to capture the flows of the stormwater, or the surface runoff there. But if there's no good spot for a maintenance person to park and access that bioswale, you could be doing a disservice because maybe the maintenance staff will continue to ignore that if they can't safely work there. You also want to avoid micro grading situations. We've worked on a site where we performed the inspection and the surface runoff was supposed to travel through a shallow grass swale into the storm sewer system. Unfortunately, that wasn't the case. That shallow grass swale turned out to be a little mound, and the parking lot grading encouraged the water to find a new path and flow offsite and cause erosion. So you just want to avoid situations where you're working with the minimum grades if at all possible. Um, this note here, note specific erosion control practices to prevent clogged media. We've seen during construction inspections, site runoff flowing into a freshly excavated bioswale with some washed stone in it already. So the runoff with sediment was contaminating that washed rock. So we communicated with the foreman there, and we had that situation rectified. But you want to make sure you're noting those specific erosion control practices. And then last but not least, make sure you get your site surveyed ASAP. Don't go crazy with your concept plans, with your GI planning. Make sure you get your site surveyed so you're not planning on putting a BMP where there's some existing utilities. So that being said, I'm right at the end of my time. Thank you for attending and listening to my presentation about MS4 BMP recertification inspections and those lessons learned. My name is Kevin Hopkins. I'm a project engineer with Aqualis. That's my contact information, and I'm open to any questions.
I thought that was really good, Kevin, especially the lessons learned about the design, things that could be done better from a design standpoint. Do you ever have problems getting plans for places that you're inspecting? Like if you're contracted by a municipality, for example, to do inspections, do they just hand you plans for everything that you're supposed to look at, or are there some gaps?
So We work more on like a site by site basis. So, as the inspector, if the business development, my partner, if he told me I'm working on this particular site and there wasn't a plan set provided by the client or the village already or the municipality, I'd reach out to either their engineer, their stormwater department, whoever's email I could find first, more or less, to at least start the question. So there are situations where there are site plans, but it's only the site plan and not like the utility plan. So doesn't have all the information we're looking for, but it's definitely a start, and we'll take what we could get.
Does pretty much everything you're inspecting have a maintenance agreement that goes with it? Or is this a situation where sometimes it's older BMPs, there's no maintenance agreement, and there might be some jurisdictional questions?
Thankfully, there have been maintenance agreements with at least the ones that I've performed. Um, yeah, thankfully, yeah, there's usually a maintenance agreement. Haven't run into many property owners just calling me up out of the blue asking for uh, their site to be inspected. Usually it's driven from a notice being sent out or some regulation, and usually that is because there's a maintenance agreement in place.
Well, thank you very much.
Yeah, thanks for having me. Appreciate it.
So, our next presenter is Dr. Faith Fitzpatrick, is a research hydrologist at the USGS Upper Midwest Science Center in Madison, Wisconsin. Over a 30-plus year career, she's worked on applied research related to fluvial geomorphology that included studies of river channel change, erosion hazards and floods, river corridor sources and sinks of sediment and phosphorus, habitat in urban streams, oil spills and oil interactions with sediment, rivers and hydrologic restoration, and hydrogeomorphology of Great Lakes estuaries. He's an instructor at the USGS and occasionally at universities locally and remotely for fluvial geomorphology and river management curriculum. And Faith is going to talk about sediment fingerprinting. So where does that sediment in streams come from? I'm hearing some kind of feedbacky noises.
It's probably, how about now? Is it still?
That's
still
better.
getting it?
That's better.
Okay.
Yep.
So maybe when I talk, my fan on my computer is running loud for some reason.
Maybe that was it. Yeah.
Turn it off. So hopefully it's okay. And can you see my screen okay?
Yes, we can.
Okay. All right. I'll get started then. And thanks for having me today. So I'll talk about over the next 30 minutes of kind of some highlights of the sediment fingerprinting and budget studies that we've been doing across the Midwest. And these got started to basically look at how streams were contributing sediment and phosphorus to downstream water bodies, and in a lot of cases in the bigger studies of field to large water bodies and eutrophication that had eutrophication problems such as the Great Lakes. And so I'll just touch on a couple of those studies today, and wanted to acknowledge my teams that have worked on these studies. We have a large number of people and partners, funding partners, collaborators from some of the federal agencies to local entities to a lot of county land conservation. So they're really a joint effort to kind of understand what's going on with what kind of the stream processes are. Let's see if that does it. Okay, so this is kind of an example of the multiple studies that we've had over the last 15 years or so, and I'll kind of key in on the Little Fork, which is one of our ones that we've just kind of finishing up. That's up in the Minnesota area and goes into Lake of the Woods. So it's been one of the largest, or thought to be one of the largest contributors of sediment and nutrients to some of the eutrophication problems that perhaps that they have at Lake of the Woods. And then I'll also kind of key in on the Kinnickinnic River in the Milwaukee area to kind of show more of an urban example too. Yeah, and so, kind of across the board then, we want to look at the main sources of both suspended and streambed sediment and what the sediment-bound phosphorus component is of those, and kind of key in on those stream corridor sources because they're kind of missing. They're like a gap in some of the models. And then we kind of fit those together with what we're getting from TMDL models. A lot of watersheds have those total maximum daily load models. And then also what the stream monitoring data might be showing as well, where there's sediment and nutrient load data collection. And part of what we can do is then get kind of a spatial look at some hot spots, and then also some temporal variability, seasonality, what's going on over flows. And then most importantly, get the results to the land managers, the water resources managers, to help in decision making and what they do for conservation practices to help limit the amount of sediment and phosphorus that are getting to downstream areas. So the sediment fingerprinting approach, and it's a combination of fingerprinting and budgets for this, but the fingerprinting part kind of fits in under the source assessment part of the TMDL process. And back in like 2016-17, we worked with EPA to take what were kind of in the research stage and come up with some tools that could be used within the TMDL process. So that's what we've been using in these studies. And again, it's to kind of combine both the stream corridor and the upland sources, and then see how that's feeding into the sediment that we're seeing in the stream systems. And then lately too, so we had kind of this field to stream monitoring and kind of looking at the budgets. Those have kind of been done a lot. Started looking at channels and the amount that's kind of coming out of the banks, and soft sediment too is like that storage part of the suspended sediment, kind of sits around for a bit, might be resuspended during floods. How much of that was in streams? That was a part of things. Oh, I see you have a hand up there. So are you having trouble hearing me?
No, you're fine.
Okay, alrighty. And then lately, kind of keyed into these gullies and ephemeral channels. Some of the studies, we were starting to see a lot of erosion kind of coming out of these kind of hidden areas. And so that's why I wanted to show the Little Fork, because we tried to quantify better that component. And that's kind of a big thing we're looking at now. So for Little Fork then, so this is up in the North Woods. This was one of our examples of a really big watershed, mostly forested, just a ton of wetland. We did have cutover forest. We have, there's roads, there's a small amount of agriculture. We had a lot of potential gully and ravine erosion, so kind of looked at that. And then also what was coming out of the stream banks. And then again, our sinks are, we're going to look at that soft, fine-grained stream bed sediment, the stuff that gets resuspended easy, and then also the suspended sediment, what's like traveling through the water column. All of these studies, too, really important piece is they have a field component to it. So we have some kind of validation of what geomorphically is going on in the watersheds, and we look at both the ephemeral and the perennial, so those dry channels and the ones that have water in them all the time, and look across a range of stream orders and slopes. We measure the amount of eroding banks and volume of soft sediment deposition. I have a couple slides on that, what the channel morphology is like, at a reconnaissance level of geomorphic and sediment process indicators, so we can get an idea of what the channel is doing or that stream is doing. And then at that time, we also collect samples for the fingerprinting part of it. And then we load those results into a GIS, stream network-based GIS, that we can kind of put things together in a budget sense. So that's where the budget part, kind of the basis of the budget comes. Again, the Little Fork, really big basin. they 46% is wetlands. So we kind of applied the channel network across there. Just it's kind of just showing you what the basin looks like. And then we also set up the suspended sediment sampling, where the state and the counties were doing their stream monitoring work as well. So we have that kind of overlap between the suspended sediment and the loads. So here's kind of the measurements for bank erosion, or if we're kind of looking at the area that's eroding. So, and then I'll show you what we do for an estimate of that bank retreat rate. And then for bed sediment, also look at the length, the width, and the thickness. So it's basically the stuff that you sink in when you're stepping in the stream. We use an NRCS's estimates for lateral recession rates. So again, this kind of comes up out of the budget end of things. And so we apply those to what we're seeing for the areas. And then to kind of convert it to what's being transported and suspended sediment, then we got to go through a volume weight conversion, and we use a generalized volume weight conversion for those bank and terrace and valley side samples that we collect. So just kind of show you how this worked for the Little Fork then, and trying to get at those ephemeral channels, like things that we know we're eroding. We see them in the field. And so we see channels. So those are kind of the thing, the field component, we get soil erosion. That's, a good chunk of people work on that aspect of things. But where are those channels at that aren't necessarily getting picked up? And so like when we're out in the field, then, we see these at like 0.02 square kilometers. So that's where then we set our, basically have to build a new stream network that takes things up to those really small watersheds in order to kind of capture those ravines and small channels where those start. And we've been able to do that pretty well with the 10-meter digital elevation model data that's available. It's nationally available. And what you see on the right there, those red lines, that's like the typical, like if you look at a map and you see blue lines and dash lines for intermittent streams, that's kind of like what you would see for the Little Fork. And all that like light blue area, it looks like almost like it's solid. Those are actually all those like extra streams that doing that finer network pickup. So we use some of the tools in ArcGIS to be able to build these networks. We look at little short segments then too. We get slopes for those. We get valley side slopes. I'll show a slide on that. So we can actually like start to account for these in our budgets then. And we try to do it in the kind of the easiest way possible, that with the methods that people would have available to them too. Because you could also do it with the high resolution LiDAR, county LiDAR data as well, but then you'd start to kind of have to mess with hydrologic connection and stuff like that. So, but it could also be done with that. So just to show you how we get at those kind of valley side slopes, it kind of took a while to get this. And we also use this for our fluvial erosion hazards as well. But it's basically looking at what, it's called the meander belt width in meandering channels. And there's been some studies that have looked at that 8 times the channel width gives you an idea of what that active meander belt width would be. So we kind of use that to then buffer our streamlines and then pick up where, like within the digital elevation model, we would have these steep valley sides show up. So that was kind of a major thing to be able to again see like what that kind of side slope, where those big kind of mass wastings might be taking place, in addition to just the usual bank erosion. But so just some examples of that, what these ravines look like, and these channels, they may be disconnected. They start with gullies, basically seeing a lot of these guys invigorating with the latest kind of floods that we've had. And a lot of them, yeah, they're hidden in the trees. You know, a lot of these were formed during the 1940s and 50s. In the steeper areas, could be in the driftless area, could be in some of our steeper glacial paleo shoreline areas around the Great Lakes, and also wherever you have a river valley and you have tributaries coming in, and so they'll be cutting through that steeper section of a bigger valley side. Here's an example of, you know, a lot of these had sediment basins put in on them that filled up. Again, they're kind of hiding in there. There's an example of one over by Blue Mountain State Park. I was just at last week or a week before last. You know, big channel kind of cutting through breach the dam, and then, you know, we're starting to see these channels reform and move upstream, and every flood they get deeper and expand in the upstream direction. So there's something to kind of look for and account for in these. So the Little Fork had a lot of bank erosion centered along its main stem and the tributaries that drain into and along the valley sides. This is kind of the yellow and the red shown on the map here on the right. And then we can also get some erosion rates, like per kilometer, what we're seeing in these basins. And if we look at the banks only, you know, they usually run about 50 to 100 megagrams per kilometer per year, you know. And then when you get into those valley sides, where you have partially confined valleys or those ravines, then you start to pick up the higher rates. There's an example too, like the Little Fork, it has this, it's very young, glacially young river. And so there's points in the river where maybe there's like glacially post-glacial lake drainage where it has some steeper sections and it has nick points that are still migrating through it. And those kind of have the highest rates. And then concurrently, those tributaries that feed into it also are down cutting, so they have high rates as well. So here's some pictures of that kind of blown up. And then soft sediment deposition. The Little Fork, like I said, it had a lot of wetlands. It has a lot of beaver, and so depending on where we sampled in these stream networks, we would pick up a lot of soft sediment behind dams. They might have been failed dams. I mean, just, you know, some evidence of them. So for the Little Fork, steeper main stems, not so much, but more, you know, in those kind of wetland settings. And it shows too, like, as we go through these, like what's kind of natural amounts of things, natural amounts of bank erosion, given the geomorphic setting versus what's maybe been accentuated because of the land cover or other things happening in the watersheds. So this is like what the sediment budget looks like. And then these headwaters with the steep valley sides, those are the things that we added by doing that extended drainage network. In the past, in our earlier studies, we would kind of rely on those kind of longer reaches in the National Hydrography data set, or like in the Wisconsin State stream network. And it was worked out much better to be able to kind of dive in and get shorter lengths and then also into those ephemeral channels. On the fingerprinting side, so I'll go into that real and gloss over that too. I kind of hit in highlights here, so please ask me questions separate from this too. You'll have my email on this. So it runs through, we have gone with doing a suite of trace elements, sediment chemistry to do this, but it basically looks at the data within each source group. We normalize that, remove outliers. It's normalized on grain size and organic content. The fluvial samples are bracketed by their source to ensure that they're kind of made up of the same pattern of trace elements. And And then that runs through what's called a stepwise discriminant function analysis, kind of like a multivariate cluster type of analysis. And then once it has that set up, then it does the unmixing part of that so it can assign it to targets. And then it runs through some error analysis too, because we want to make sure that the sources are identifying the targets. The targets are the fluvial samples. So there's 3 types of error analysis that are done: a confusion matrix, the source verification test, and a Monte Carlo test. So for the Kinnickinnick then, I'll just kind of run through these so you can see that. So this is a smaller watershed, Milwaukee, totally urbanized. This is a study that we did with Milwaukee Metropolitan Sewerage District, and Jim Blount took the lead on this one. So some of you might know Jim from, he also did some stormwater sampling with the USGS too for a bit. So for there, we looked at, we had industrial, commercial, we have residential. So we go in and sample the sediment that we're getting off the streets in those cases. And then also look at the green spaces like parks, and then also the banks. And then here's an example of what these suspended sediment passive samplers look like. They're tube samplers, and then soft sediment collection. So these are all composites, as well as these as well. And there's been some standardized methods for how those are collected that I won't go into in detail here, but I can provide. So some of the results then, like this, so here's the sediment chemistry. And one of the things, this is an urban basin. So some of the, we can pull out some of the kind of legacy metals and see how those go. That's kind of a separate thing, but that's kind of also in there too. One of the things is looking at this sediment phosphorus concentrations. And Kinnickinnick is an example where we see our suspended and our bed samples are typically higher in phosphorus than our source samples. And this happens when we have basins with a dissolved phosphorus component to them. And it kind of like leads us to think about how the sediments might be reacting with the dissolved portion, either while they're in the water column or also while they're on the bed. So that's kind of a angle of things I won't talk about today, but there's studies out there on that. And then that sediment budget part of things here, if we look at the amount of bank erosion and bank erosion related to the sediment P concentrations, down at the gauge, we kind of add things up. We estimate there's about 1,100 tons, metric tons per year, and then 780 kilograms per year for that sediment bound phosphorus piece of that. And then we can kind of look at like, whoa, what are we seeing for the TMDLs for the Kinnickinnick, and how does that compare? It's about half of that. And then this is much lower for the TP. So again, kind of pointing to the other sources for that. And these are different depending on what those land uses are like. Here's the results for the suspended sediment. So this is what the fingerprint looks like as we work that out. The suspended sediment samples are collected monthly over a range of flows. And the yellow in here, that's the residential. The blue is banks, and green is the green spaces. These gray areas are ones where there either wasn't enough flow, so we didn't get samples, or maybe missed something, like if something happened to the sampler or got washed out or something like that. And you can see that there's a lot of residential source, not surprisingly, in this watershed. There's also, as we got up into this part, the Jackson part, there's more naturalized banks in there. That string gauge is still at the concrete channel there. So not expecting to see as much bank erosion there. Wilson Park Creek kind of drains the airport area. It's also concrete. So we're kind of picking up more of a residential signature there. We can then kind of sum up things over the study period 2 of what we're seeing with suspended sediment. And then this is the stream bed sediment, and here's Wilson Park and Jackson Park in the northwest part, and then the stream gauge to the right. But this is kind of usual where we see more of a bank component to the stream bed samples, probably because it's accumulating over a longer time period. Okay, so source verification test 2, I just wanted to show this. This is like results for each sample and then how those sources fit. So this is like a really good result to see that, you know, like we have 16 of each of these source samples, and in general, they fit across the range of, this is our stream bed samples, and this is our suspended sediment samples. We don't always get that. Sometimes there's more of a mix between the land uses, but it kind of gives us some confidence in the results then. And for this one, you know, I wasn't sure if we would be able to see a difference in the streets between the industrial, commercial, and the residential, right? Because they kind of overlap, but it was able to pick that up. There's some other categories too in more of the rural settings. Forested and ag and grassland, there's some overlap sometimes between those depending on what the past history has been. So based on that too, we're starting to build a library of source samples across the Midwest. So far, this has worked the best with the agricultural setting to be able to go between the different watersheds, and then that helps to save some time and funds to be able to kind of reduce the number of samples. So lessons learned then, those estimates of corridor erosion, you know, we are kind of looking at a big range, and not surprisingly, you know, with other studies kind of showing the same thing, where it might account for half to like over, you know, 100% of what you might be seeing with the loads. Though it just kind of further justifies looking at the sediment and what's going on in the stream corridors, and especially in that kind of gully ravine and ephemeral channel setting. And that we need, you know, in order to do that and put those into budgets and kind of work out the overall amounts using a more detailed channel network to be able to do that. Again, we might have higher phosphorus concentrations in those stream sediments than we see from the sources. That amount of stored sediment, it varies geomorphically amongst the watersheds. And so that's also another thing. We just kind of think about it in terms of like, if it gets resuspended, is there, and if there's a lot of it, is it giving a lag time between what you might see for field or other BMPs versus what you're seeing at a stream monitoring station? And again, building that library. And then here's the publications that have been coming out. Did want to highlight Heidi Broman. We're working on the East River currently, and she's giving a talk tomorrow, is Thursday, right, at AWRA in the afternoon. So if anybody's going to AWRA and wants to hear more, she'll be talking about the East River and our results there. And that's it. Thank you.
Thanks. It was a lot to digest.
Sorry, I was trying to like not make it as much, but
my takeaway, one of my takeaways was that in the more densely urbanized areas, the stream bank erosion is contributing a smaller, like whatever, 10 to 20% of the sediment load in the river, but the less urbanized the area, the more that percent of stream bank erosion contributes, up to maybe it looked like 90+% in some areas.
Yeah, and it can account for like more than maybe what's showing up in the loads because of like, you know, some differences in the time scales, and then also what other storage pieces are in there from when it goes from banks into suspension. So yeah, definitely. Yeah, and the Kinnickinnick was interesting because it's so much of it is still concrete lined, and then being able to like still see the signatures from the banks. And then similarly too, when we do have small amounts of something like the green spaces, or if we have a high amount of stream corridor erosion, sometimes that will dilute out the ag signature that might be coming from higher in the watershed too. So we see so much from the ag, but then as we get down in some of these really entrenched valleys and bigger watersheds, then the amount of bank erosion will kind of take over.
In the areas where there was more phosphorus in the sediment, in the stream sediment than there was in the source areas, is that because somehow like trees are dropping leaves, which doesn't register in the source area sediment, but somehow it's getting precipitated in the stream and you're picking it up there?
Yeah, didn't see it too much in the Little Fork, although there was some interesting results between amazingly, it was able to distinguish between recent cutover and not, and if the air horizon is intact in the forested systems, there's more phosphorus, particulate bound phosphorus in those intact soils, and there was less in the cutover. So that was interesting that there is like this potential contribution from organic rich sediments that may be coming off of the cutovers. Otherwise, it's usually like the East River is probably one of the highest dissolved where there's like liquid manure applications. So the places where there's manure applications, or like in the Kinnickinnick where there's dissolved phosphorus coming from other sources than urban sources, then we see that.
Well, thank you very much for an excellent presentation. Really appreciate it.
Thank you. Okay.
So, do we have Demetra online? Yes. Okay. You weren't registering at the top of my screen, so I was uncertain. Attorney Demetra Christopoulos is managing attorney at the Waukesha County Office of Corporation Counsel. She advises the Register of Deeds, County Treasurer, Department of Parks and Land Use, Sheriff's Department, and Purchasing Division of the Department of Administration. With a passion for public sector work, Demetra has built a reputation for delivering exceptional legal counsel. With over 14 years of experience, Demetra brings a wealth of knowledge and practical experience to her work. Outside of the office, Demetra enjoys spending time with her husband and 2 children, exercising, and spending time with friends and family. And she graciously agreed to present about engineering ethics. So, Demetra, I'm going to turn my screen off, and when I show back up, it'll be time to get close to wrapping up.
Good morning, everybody. Let me just share my screen here. All right, and are you able to see the PowerPoint now, Leif?
Yep, we're good. Thank you.
Awesome. Okay. All right. Good morning, everybody, and welcome to the importance of ethics in civil engineering. Thank you for that introduction. My name is Demetra Christopoulos. I am a Principal Assistant Corporation Counsel with the Waukesha County Office of Corporation Counsel. And as we get started, I just want to give the typical legal disclaimer. Nothing in this presentation should be construed as legal advice. So if you do have any legal questions, please direct those to your designated legal counsel. So today we are going to talk about ethics. And, here we go. We're going to touch on a little bit of the rules of professional conduct under the Wisconsin Administrative Code, also the National Society of Professional Engineers Code of Ethics and their role in your professional rules, And then I thought we could do a little dive into conflicts of interest specifically, honesty, and then talk about potential legal consequences if you fail to abide by the rules of professional conduct and some best practices moving forward. So first and foremost, what is ethics? Professional ethics is a set of standards defined by the professional community, which provides a guide for behavior that is expected from the professional. So ethics is something that's fundamental to your profession. As engineers in Wisconsin, you don't just build roads or bridges and water systems, you also build trust. And if you think about it, every project you undertake directly impacts the lives of the people in your communities. When you design a bridge, you're responsible for the safety of everybody that crosses that bridge. When you manage stormwater, you're safeguarding the health of our waterways. And when you develop land, you're shaping the future of our communities. This responsibility comes with immense power, and with that power comes that absolute necessity for unwavering ethical conduct. The public is placing their trust in you. Unethical behavior, even seemingly small lapses in judgment, can have devastating consequences. It can lead to project failures, environmental damage, and most importantly, the loss of life. So here in Wisconsin, we operate within a specific regulatory framework. The Wisconsin Department of Safety and Professional Services, or DSPS, sets the standards for your practice. They ensure that you uphold the highest levels of professionalism and ethical conduct. The Wisconsin Examining Board for Engineers has established specific rules of professional conduct under Chapter 8E of the Wisconsin Administrative Code and also under the statutes. These rules are designed to ensure ethical and professional behavior, to protect public welfare, and to also maintain the integrity of the engineering profession in Wisconsin. So today we're going to dive into some of these core ethical principles that guide your profession and specifically as they apply to your work in Wisconsin. Just remember, ethics really is the foundation upon which your profession stands. It's the commitment you're making to the public, your colleagues, and yourselves. So Chapter AE8 of the Wisconsin Administrative Code provides guidelines for ethical conduct for engineers practicing in the state. DSPS regulates and oversees ethical standards for licensed engineers. They also handle complaints, investigations, and disciplinary actions for unethical behavior. There are some key professional conduct obligations under Chapter AE8. These were the 6 that I identified that were major themes that I saw under Chapter AE8, and then as well as the NSPE Code of Ethics. Honesty seems to be the first and foremost. It really is the underlying factor in everything that you do. Avoiding conflicts of interest, competence and scope of practice, obviously avoiding unauthorized practice of the profession, your professional responsibility to the profession and reporting violations to the board, and adhering to statutes and codes. So I've also put in the references in the code that speak to these specific professional conduct obligations. The National Society of Professional Engineers, or as I will call them, the NSPE, and I'm sure you know them as that as well, plays a supportive role in regulating and advancing professional development with professional engineers in Wisconsin. Specifically, the NSPE or its affiliates are recognized as approved providers for continuing education programs here in Wisconsin. And their code of ethics serves as a widely recognized standard for ethical engineering practices. Although adhering to them is not mandated by Wisconsin law, a lot of their code of ethics really is consistent with your professional rules under the administrative code and statutes. Oops, I'm sorry, I went to click the button here. So the NSPA Code of Ethics and their creed has a fundamental canon, and it's as a professional engineer, I will dedicate my professional knowledge to the advancement and betterment of public health, safety, and welfare. And this really resonates and is consistent with Chapter 443 of the Wisconsin statutes, as well as Section 806 of the Administrative Code. 44306 defines professional engineering as a professional service requiring the application of engineering principles in which the public welfare or the safeguarding of life, health, or property is concerned and involved. And then under 806 of the Administrative Code, it states that a professional engineer may not enter into an agreement that provides a person not legally actually qualified to perform the professional services has control over judgment as related to public health, safety, or welfare. So this is something that's paramount and guides the work that you do. When you look at the fundamental canons of the NSPE Code of Ethics, a lot of that, again, is consistent with the administrative code. So number one, holding paramount the safety, health, and welfare of the public, performing services only in your area of competence, issuing public statements only in an objective and truthful manner, acting for each employer or client as a faithful agent or trustee, avoiding deceptive acts, and conducting yourselves honorably, responsibly, ethically, and lawfully so as to enhance the honor, reputation, and usefulness of the profession. So again, these key ethical obligations are very consistent with the administrative code. Again, protecting public health, safety, and welfare, truthfulness and honesty, competence and scope of practice, confidentiality being maintained, avoiding conflicts of interest, following the law, and professional responsibility. So what is a conflict of interest? It's generally defined as a situation where a professional's personal or financial interests could compromise their professional judgment, integrity, or responsibility. So there could be different sources of conflicts of interest. You could have a financial interest. Maybe there's a professional interest in deciding one way that could impact a business that you own in a positive way. You might have a personal interest in the outcome of a specific project, or you might have some prejudices towards how something should be done because of one of these other interests that you might have. Section 805 of the Administrative Code is specific to conflicts of interest. And first and foremost, it says you should avoid them, right? If a conflict of interest arises that's unavoidable, then and it might interfere or impair with your obligation to provide your professional services, you need to provide full disclosure and then obtain consent of the client or the employer. Subsection B says that you should notify the employer or client and withdraw at any time if it becomes apparent that it's impossible to faithfully discharge the responsibilities and duties owed to the client or employer. Subsection C says you may not agree to perform professional services for a client or employer if you believe you have a significant financial or other interest which would impair or interfere with your responsibility to faithfully discharge the professional services on behalf of the client or employer. Subsection D discusses payments, and so you may not accept payment from any party other than your client or employer for a particular project, or have any direct or indirect financial interest in a service or phase of a service to be provided as part of a project unless the employer or client approves. You may not solicit or accept anything of value for material or equipment suppliers in return for specifying or endorsing a project or product. And you may not violate the confidences of a client or employer except as otherwise required by the rules in the chapter. And you may not perform services for a client or employer while a full-time employer of another employer without notifying all the parties concerned. So if you see Chapter 8 really speaks to those different types of situations where you might have a financial interest, a personal interest, or a professional interest that could be adverse to the job that you've agreed to do. The NSPE Code of Ethics also speaks to conflicts of interest under Section 2, their rules of practice, and Section 3, their professional obligations. So Section 4 of Section 2 of the rules of practice says that engineers for each employer or client will act as faithful agents or trustees. So again, it's pretty consistent with the administrative code. I would say that the Code of Ethics here is a little bit more detailed, so it's always instructive to review these as well. But again, disclosing potential conflicts of interest that could influence or appear to influence your judgment or quality of services, not accepting compensation, financial or otherwise, for more than one party for services on the same project, not accepting or soliciting financial or other valuable consideration from outside agents in connection with work that you're responsible for. And subsection D, I think, is a very detailed and a little bit more than the administrative code. Engineers in public service as members, advisors, or employees of a governmental or quasi-governmental body or department shall not participate in decisions with respect to services solicited or provided by them or their organizations in private or public engineering practice. We'll touch on this one in a little bit with a case example. And then engineers should not solicit or accept a contract from a governmental body on which a principal or officer of their organization serves as a member. Again, that might impact your ability to perform your work and not have some kind of bias or personal interest in it, the outcome. Section 5 of Section 3, professional obligations, also speaks to conflicts of interest. And again, here, engineers should not be influenced in their professional duties by conflicting interests. And this speaks to financial or other considerations or accepting commissions or allowances. So the NSPE Board of Ethical Review cases are advisory opinions that interpret the NSPE Code of Ethics in specific ethical situations and provide guidance to engineers on ethical dilemmas they might face. So the NSPE BER considers ethical cases, both real and hypothetical, submitted by NSPE members, other engineers, public officials, and members of the public. There are nearly 650 advisory opinions aimed to clarify ethical issues engineers encounter on a daily basis. So this case I thought was relevant to conflict of interest violations. The case is BER case 97-4. In this case, engineers A and B were in a joint venture in an engineering and construction management practice that provides civil and municipal engineering and construction management services for clients in a number of townships in the state. The joint venture was hired by a developer to design a 90-lot subdivision in Township A. Engineer provided the engineering design, and Engineer B provided construction management services for the project. During a review by officials in Township A, it was determined by the officials that a second road would be needed to access the subdivision. However, the second road exited into Township B, which was adjacent to Township A. Engineer A and B's joint venture also owned undeveloped property in Township B, and their joint venture also served as municipal engineer in Township B. It was clear that the property owned by the engineers would be positively affected by construction of the new road. As municipal engineer for Township B, the joint venture of engineers A and B disclosed that relationship with regard to Township B, A with a developer to Township B. Bit of a puzzle here. What they didn't disclose was their ownership of property in Township B. With that information available to them, not the information of the ownership of the property, Township B didn't object to the engineers recommending the feasibility of the construction of the road. Thereafter, the municipal engineer for Township B Engineers A's and B's joint venture recommended the township be approved construction of the proposed road. So the questions presented were, would it be ethical for engineers A and B to serve as the engineers for the developer and also serve as municipal engineer for Township B under the circumstances described? The second question posed was it ethical for engineers A and B to recommend approval of the road under the circumstances described? The BER determined it was not ethical for engineers A and B to serve as the engineers for the developer and also serve as municipal engineer for Township B because there was only a partial disclosure and absolutely no disclosure of their ownership of undeveloped property. It was not ethical for them to recommend approval of the road because as employers or advisors in public service to Township B, the engineers should not have participated in decisions involving professional services provided by them in their private practice. Next, we're going to talk about honesty. And I'm running a little short on time, so I'll try to breeze through it a little quicker. Chapter AE discusses honesty in the administrative code, and then again, very consistent rules under the rules of practice and the professional obligations of the NSPE Code of Ethics. So Chapter AE, Section 804 discusses honesty. When offering to perform professional services, you should accurately and truthfully represent to a prospective client your capabilities and qualifications to perform the services rendered. You should represent the costs and completion times of a proposed project to a client as accurately and truthfully as is reasonably possible. You shouldn't offer to perform services that you're not qualified to perform by education or experience without retaining the services of another who is qualified. Avoid deceptive or fraudulent advertising or publicity. And don't misrepresent the extent to which the performance of services will involve a partnership or association with another that will also engage in the performance of services. You may not collect a fee for recommending services of another unless written notice is given to all first. And you may not practice under a firm name that misrepresents the identity of those practicing in the firm or misrepresents the types of services which the individual firm or partnership is authorized and qualified to perform. So again, a lot of this honesty is speaking to your qualifications, your competency to perform your services, and then to truthfully render the services to the client as well. The NSPE rules of practice is very consistent. Again, speaks to public statements, being objective and truthful in your reports, and making sure that any technical opinions are founded upon knowledge of the facts and competence in the subject matter. And then Rule 5 is, again, very duplicative, but says avoid deceptive acts. So don't falsify your qualifications or permit misrepresentation of yours or your associate's qualifications. And then Rule 1, Section 3 says you should be guided in all your relations by the highest standards of honesty and integrity. And I thought this one was important because everybody makes mistakes. And what's important about that is acknowledging errors and not distorting or altering the facts to try to cover them up. Being honest when a project might not be successful and not accepting employment to the detriment of your regular work or interest. And then not promoting your interests at the expense of the dignity and integrity of the profession. And then you should look to Rule 3, Section 3 as well. Again, very consistent, avoid deceptive conduct and behavior. So we'll breeze through this honesty violation real quick. I thought this one was interesting. So engineer A was contacted by client B and seeking engineer A's services as part of the design of a new facility for client B. Following discussions with client B regarding the scope of work, engineer said, this is what I think it's going to cost you, best case scenario. The problem was that engineer A was doing a very similar project nearby for another client and encountered unanticipated site conditions that resulted in significant additional time for this engineer. The engineer did not disclose those unanticipated site conditions to the new client, and that it might result in significant additional time and cost for this new client. So the question was it unethical for engineer A to fail to disclose to client B the unanticipated site conditions that result in a significant additional time for engineer A to complete the final design for client C? And the board concluded, yes, it was. Honesty is always the best policy. So engineer A really should have disclosed to client B the previously encountered site conditions, and that way client B could have made an educated decision and perhaps budgeted for what might come, or decide to go elsewhere with how he wanted to proceed with the project as well. Can I keep going, Leaf? I've got like 2 more slides.
Go ahead.
Okay. So I also wanted to talk about some legal considerations of unethical behavior. So Section 443.11 of Wisconsin statutes says that disciplinary proceedings against architects, landscape architects, and engineers and registered designers can occur. And then 443.18 discusses penalties and law enforcement. So consequences can include suspension or revocation of a license, fines and penalties, lawsuits and civil liability, and also potential criminal penalties. So how can we uphold ethical standards? Transparency and communication. It's essential to be open about potential issues with projects and to always disclose any conflicts of interest. This helps maintain trust and ensures everyone is making informed decisions. Accountability. Engineers need to take full responsibility for their work. When mistakes happen, own up to them, correct them. That's vital. And a culture of accountability is crucial for your profession. Seek guidance. Ethical dilemmas can be tricky. The ones I posed were pretty straightforward, and it's okay to ask for help. There are resources like mentorship, legal advisors, and ethics boards that can provide guidance to you. Professional development. Ethical standards aren't static. So by continuing to learn, you stay sharp and aware of new challenges, technologies, and regulations. And then promote those ethics in the workplace. If you see something, report it and adhere to your code of ethics. And always remember that above all, every decision you make must prioritize the safety and well-being of the public. And with that, thank you for your time.
Thanks. That was really helpful, especially I thought the case studies were especially interesting because that brings to light what some of the legalese and the standards themselves are trying to convey. But one thing that I've experienced myself is, the state develops standards for things like best practices or how to build a bridge or things like that. And to write those standards, they bring in experts in the field who tend to be, engineers, consultants, and so on. So, and the engineers are writing the standards for things that they're then going to implement, which in some cases seems like it could cause a conflict of interest. But I suppose if they do it with integrity and, once that standard is written, it's not directing work necessarily to them. Anybody could do the work that makes it an acceptable process.
I think that's part of it, right? Is that it's not specific to a project. It's setting forth standards for safety, right? And what's expected as a baseline. And I would imagine that they're also disclosing those potential conflicts and stating, this is where I'm employed, this is my role. Everybody has full knowledge of that, right? Before they continue on and enter into that relationship.
Exactly, yeah. Well, thank you very much. Really appreciate your taking the time. I know you must have invested a lot of effort in putting that together, so I really appreciate it.
Yeah, of course. Thank you for asking me to join and enjoy the rest of your training today.
Thank you very much.
Right, bye.
Well, Kelly, we have a couple polls. Why don't we run those real quick here? And this would be a chance, if somebody needs to take a short break, this would be a chance to do it. So this poll is about where are you coming from? Give it another minute yet. And looks like that's probably pretty much everybody that's going to enter. So we got about roughly 60% consultants, 15% land conservation, 12% public works, 5% other municipal, 2% other consultants, no DNR, 2% developers, 2% contractors, and 4% others. So, and then the other part of the poll at the bottom is about we had a few issues with communications leading up to the workshop, so we're trying to find out. Obviously, the people that are here must have gotten the message at some point, but we'd like to know, how you got it. So 11% of the people that are tuning in did not receive any emails about the event. And for 9%, they did get them, but it went to their spam folder. So that's something we'll try and address in the future to see if there's some way to get around that firewall issue that caused some problems for a few people. So good. Well, thank you very much. So next presenter coming up is Grace Barlow from the DNR. It's going to talk about the MS4 BMP menu website. Grace Barlow is a stormwater specialist with the Wisconsin DNR who focuses primarily on construction and municipal compliance and enforcement. Prior to this role, she was a permitting technician for Minnehaha Creek Watershed District in the Twin Cities area, reviewing and issuing permits for a number of watershed regulations, including watershed management. Outside of work, she's an avid rock climber and is the head varsity coach for Whitefish Bay Nicolay Shorewood High School girls lacrosse. She has a BA in biology from Oberlin College and a master's in freshwater science from UW-Milwaukee. So Grace, I'll turn it over to you. I'll disappear, and when we're getting close to time, I'll reappear.
Awesome, thank you. All right, just checking that everybody is good on my screen, hopefully.
Yeah, we can see your display and we can hear you.
Great, well, good morning, everybody. I'm here today to present a resource that the DNR has been working on for the past year or so. It is a best management practice menu for our MS4 permit program. For our presentation today, we're going to go through the following, just a super brief overview of the MS4 permit for those who are not familiar. What even is a BMP menu or a best management practices menu using the EPAs as an example? A little bit of background into the DNR specific BMP menu that was created and how it differs from the EPAs. And then finally, just a quick tutorial, what you can find within the menu, and some of the really good resources that are included in it. For some context, the MS4 program is the Municipal Separate Storm Sewer System program. This is a permitted program, and it requires municipalities to reduce polluted stormwater runoff by implementing stormwater management programs that contain specific best management practices. Municipalities that are required to have this permit are established based on things like urbanized area, population size, as well as a few other factors that are outlined in state code. Municipal stormwater is a point source of pollution. However, unlike more traditional point sources of pollution like wastewater that use water quality-based effluent limits and technology-based effluent limits, the MS4 permit, which is a point source discharge permit, uses the term maximum extent practicable as the defining factor for how pollution needs to be reduced. So what is a BMP menu? In October 2000, the EPA created a national menu for stormwater best management practices, specifically for the MS4 permit. And their BMP menu outlined some additional information for the 6 minimum control measures, which are the programs that are outlined within the MS4 permit. So this includes public education and outreach, public involvement and participation, illicit discharge detection and elimination, construction site pollutant control, post-construction stormwater management, and pollution prevention. Like I said, it just provides information and resources on kind of the broader topics for these programs, but it's not specific to Wisconsin's MS4 permit program. Some states created their own. Other states continue to reference and use the US EPA's. However, because the national menu is pretty broad, this led to a lot more questions and confusion for MS4 permittees within the state of Wisconsin. So the Wisconsin DNR rolled out our own menu, developed to, provide a little bit more focused information for MS4 permittees within the state that are looking for compliance with their permit. Specifically, the menu provides resources and examples which may help permittees choose appropriate stormwater strategies under their permit requirements. It includes information and resources, again, for the 6 stormwater management programs, just like the national one. But it also includes additional information for TMDLs and impaired water requirements that are specific to our state. And it also includes current Wisconsin DNR publications that are relevant to the permit. And what we're most excited about is it includes a lot of example MS4 compliance documents and tools to help prepare MS4 permittees for an audit, for challenges that may arise as these permittees look to implement the permit, and just to help permittees assess the effectiveness of their own programs. A quick overview as to who benefits from this. Why would the DNR take the time to do this? We want to believe that everybody benefits from it, everybody down to the public who might be interested in learning more about municipal stormwater. But for some specific examples, municipal employees for a municipality that has an MS4 permit, if there are questions about how to comply with the MS4 permit, if you're looking for examples of written program procedures so that permittees can write their own or improve the written procedures that they already have, or if they are about to be audited by the DNR and are looking to prepare, definitely are going to benefit from checking out this resource before those items happen. There are a lot of people on this call that are working for consulting firms. If you need to find information or guidance on TMDLs, check out the BMP menu. If you are working with an MS4 permittee and you need to develop a stormwater pollution prevention plan, or if you are looking to help them develop written programs and procedures, the examples that are listed within this resource will be really helpful. And it will benefit DNR staff as well as we continue to refine guidance and identify gaps in information. So if you are looking to find this wonderful resource, head to the Wisconsin DNR's Stormwater Runoff homepage. You can also just Google it. I'm pretty sure it'll be the first thing that pops up if you Google Wisconsin DNR MS4 BMP menu. But if not, you can head to our homepage, scroll to the bottom and select the tile. All right. So with that background, I'm going to take a second to kind of navigate through the resource. I'm going to have to. There we go. So this is what the landing page of the menu looks like on our website. There is a quick disclaimer that, again, this is intended solely as a reference tool. It's not an all-inclusive list, and it doesn't preclude MS4s from using any other technically sound practices. This is just, again, compiled by the DNR, compiled by stormwater specialists who have been working in municipal compliance for a while. When you get to the landing page, you'll come across the directory, and your options to go through are kind of the first one is the stormwater management program. So the 6 minimum control measures that are outlined within the permit, as well as an MS4 map. This page talks a little bit about measurable goals. That's often a question that we get when we're working with permittees. So if you're a consultant or if you're a municipal worker who has questions about this, this is a really good area to kind of clarify what the concept of a measurable goal is. Talks again about written program procedures and why that item is so important to the MS4 permit. And then for each of the programs that an MS4 municipality has to run under the permit, we have examples of written program procedures for each of the 6. So public education and outreach, public involvement and participation, your illicit discharge program, construction site, post-construction, pollution prevention. And then if you want to look at an accurate map of which municipalities in the state currently have an MS4 permit, you can access that here as well. The big thing, again, for this page is just the fact that we have really strong examples of what written program and procedures look like for each of these 6 programs. We do a lot of audits. These resources were determined kind of based on some of the feedback that we get from these audits. So we as the DNR know that that's an area that a lot of municipalities were looking for guidance on. So we're hoping that having these examples on the website will really benefit people going forward. On the second option that you can click and go through is for TMDLs and impaired waters. Again, we've got good resources for that. We have TMDL guidance, we have information for modeling, and then we have some kind of concentrated links for all of the various lists of impaired waters within the state, fact sheets on developing TMDLs, approved TMDLs, and even down to like our most, even down to some of the most common pollutants as well, and helpful resources for that. Within the state, we have individual and general MS4 permits. We have every MS4 permit as a part of this resource. They are broken down by region. So if you want to confirm whether or not you're under a general permit, an individual group permit, or an individual permit, you can double check that here. And then all of the individual permits are also listed, again, broken down by region. And they also have the fact sheets associated with them. So again, just some targeted information. We want to make it easy for everybody to find the things that they need. And that's a great place to do that. And then finally, this chunk on MS4 audits, we're really hoping, or we're really excited about, and we're really hoping is going to provide value to people, you know, all of the various municipalities, consulting firms across the state. For those who don't know, an MS4 audit is essentially a compliance check with the DNR. It's where we sit down with the municipality and go through how the permit is being implemented, identify areas of noncompliance, provide recommendations about how things could be running a little bit better. These can be, I think, intimidating for municipalities. So we worked hard to prepare a checklist for municipalities that are about to be audited by the DNR so that you can go through, you can use this checklist to assess your own program before the DNR sits down and maybe picks it apart more than you were hoping that we would. So we're really hoping that municipalities can use this. You can use it at any time. You don't need to do it just to prepare for an audit, but we're excited that, you know, there's some better resources to help our municipalities prepare for the audits. And because ultimately we just want people to be implementing this well for water quality across the state. So this is a really excellent resource to help with that. And then finally, various additional resources, information, up-to-date information regarding grants and other funding opportunities are listed here. As part of the MS4 program, there are kind of these newsletter regional highlights that get put out. They're listed here. And then common MS4 questions that get provided to the DNR and to municipalities as well. If you're looking for a resource to send to private landowners, to homeowners about some of the things that we get questions on the most, this is a great resource to have on deck for that. So that was quick on my end, but we just wanted to provide everybody with kind of an overview, let people know that this tool does exist now, and we're really hoping that it provides a lot of benefit to municipalities, to consultants, to engineers across the state.
Yeah, thank you. That looks like a lot of really useful information.
A lot of information, but we really encourage people to check it out. A lot of thought went into it, a lot of time went into it. So we know that it's a good resource, and we're excited to share it.
Yeah, I know for myself, I'm definitely going to check out the page about the municipal audits because I'm sure we're going to be on the list at some point. So I'll try to make sure that we're as well prepared when the time comes as possible.
Of course.
Well, that was really excellent. I don't see any audience questions, so I'll just say thank you very much for taking the time to present.
Yeah, of course. Thank you.
I think let's take a 10-minute break here since we're a little bit ahead of schedule. So we'll reconvene at 10:30. So see you all in a little over 10 minutes. Well, it's 10:30, so why don't we pick up where we left off? So the next presenter we have is Samantha Whitens from the DNR, who's going to be talking about the Vista Sands Solar Farm and then about solar permitting and stormwater management in general. Samantha works at the DNR and is the stormwater engineer for the Office of Energy. Her responsibilities include reviewing the stormwater and erosion control plans for energy projects proposed throughout the state. Many of her projects involve the review of solar construction projects, which can range from 1 to over 10,000 acres. 10,000 acres. So, Samantha, why don't you take her away? And do you have your presentation queued up? Okay.
Yes, I do. Let's see here. Let me know if you can see that.
Yeah, it's still in the full screen. Yeah, there you go. Okay. Yep, we can see and hear. So I'm
Perfect.
gonna disappear. I'll pop up when you're getting down to a few minutes.
Perfect. Okay. Yeah, good morning, everybody. It's super gloomy outside, so I hope my my lighting situation is appropriate in here. Yeah, I'm going to be talking about solar in Wisconsin and solar generally, and then I'll be transitioning halfway through into talking about Vista Sands. So let's see. Okay. This is a fun little picture. I took this at a solar project in Southwest Wisconsin a couple winters ago. I was told that it was a safety snowman, and he was featured in the site crew's daily safety briefing. He's got his hard hat on, so that was pointed out to me as well. But yeah, I'll be going through a little background about solar in the state, different types of solar that we see, trends nationally, as well as predicted trends that we're anticipated to see here in the state. And then I will switch over to Vista Sands at the end. So, yeah, solar is a pretty complex construction type project. So initially, I had said that it ranged from 1 to over 10,000 acres, but now it's a little bit smaller than that, probably not for long though. And we're about just over 7,000 acres, around 7,100, I think, and that is actually going to be Vista Sands. That is going to be the largest solar project that we will have in the state by about 3 or 4 times. So currently, I think the largest solar project that we have is Badger Hollow, which is in Cobb, Wisconsin, between Dodgeville and Montfort. So another cool thing about working with these utility scale solar projects is that we have developers from all over the country. So I know we had some developers from out west, which was really interesting. You kind of get a feel for how things are done in other parts of the state. But it also makes it kind of challenging because we have such a unique climate here that presents a lot of challenges for construction throughout the year. In the winter, we don't bat an eye if it gets to be minus 45. And in the summer, it can be over 100 degrees. And just the variability on our soils and in our weather patterns makes it really challenging to construct here that other parts of the state just don't, or other parts of the country just don't experience. So yeah, it's been a lot of relationship building with different developers from all over the country. And we even had one development that was part of Samsung, so international development as well. So a very interesting and unique feature of working on these big energy projects through our Office of Energy. So this last bullet point here, I pulled from a Public Service Commission draft assessment last year, but they anticipate that Wisconsin is going to add about 6,000 megawatts of new energy by 2030. So for reference, I think Vista Sands is about a little over 1,300 megawatts. It's anticipated to be. But again, that is massive. So typically we see projects more so along the lines of 100 to 300 megawatts. So it's going to be pretty substantial. So the three main types of solar that we see are residential, community, and utility. So from a stormwater perspective here at DNR, we only come in, or our regulations only come into play when there's disturbance greater than an acre. So we don't deal with any of the residential rooftop solar installations, but we do work with community scale and utility scale developments. The community scale projects are a bit smaller. They're usually around 50 acres or less. And I think last year we had around 30. And I'm pretty sure next year we're going to have maybe twice as many. So those are on the up and up. And the utility plans, they can range up to Vista Sands size. And I'm sure it won't be long until we've got an even larger one. So there's a lot of variability. So I threw this in here just to, I guess, provide some context about where we in Wisconsin stand compared to the rest of the country. So these are the top 15 solar energy producers in the country. So obviously California, Texas, Florida are at the top of the list. California and Texas, just because they're huge, they have a lot of space to add solar, and Florida because they've got a ton of sunshine. But I think it's funny. Wisconsin made the list. We are number 14 of 15, but it still counts. We're still on the list. So to dive into that a little bit more, of those 15 states that produce the most solar energy in the country, here's a breakdown of just how much that is. So again, Wisconsin basically gets like the honorable mention here. So we have this tiny little 1% sliver. You probably can't even see it, but I promise it's there. But that's okay, it still counts. And diving into that a little bit more too, I put these percentages at the bottom for specifically Wisconsin power generation. So only 1% of our power generation is solar, but we're mostly natural gas and coal at this point. So I'm not sure where that's going to go. So I grabbed this snippet probably a year or two ago, and now with things changing federally, I'm not sure how these numbers are going to change in the next few years, but it will be really interesting to pay attention to what we anticipated versus what we're going to experience. So I definitely recommend paying attention to that. It'll be definitely interesting. And I did not have a good transition slide between that and Vista Sands. So this is my segue. And it is a woman on a Segway that I stole off the internet because we're going to segue into Vista Sands. So here is just an overview of the general layout for Vista Sands. So I'm not sure if you can see my cursor on here, but up at the top, just to give you a little reference here, this is the Wisconsin River up at the top. over here on the left side of the screen, we've got the county line between Wood and Portage County. And then over on the right side, we've got Highway 39. So this project is pretty much contained within those boundaries and all within Portage County. So pretty substantial. And I'm sure most of you have heard of Vista Sands for whatever reason, but I have a feeling that it's probably due to the controversy around prairie chickens. So the proposed project is just a little bit over 7,100 acres. And it's anticipated to produce about 1,300 megawatts of electricity, which is enough to power 200,000 homes. So just thinking about my little town, I live in a tiny town with like 1,500 people. So it's kind of crazy to think about the scale of this project. But it'll be located in the towns of Plover, Buena Vista, and Grant, and very contentious due to its proximity to the Buena Vista Wildlife Area, which has some of the last remaining suitable habitat that is specifically managed for the prairie chicken population. So this project garnered so much attention through the Public Service Commission review process, just for its proximity to this sensitive population of prairie chickens. So you guys are going to have access to the PDF of this. So I threw in this link here so you can access it later, but I'm just going to click on these links that I have here. Are you able to see this?
Yes, we are.
Okay, perfect. So a visual is always better because it's kind of difficult to explain this, but so for reference, if you see the state of Wisconsin here,
I'm
just for
sorry, no,
reference.
we do not see the PDF. We still see your main screen. You might need to
Okay.
reshare perhaps.
Sure. Yes, let me do that. Okay, let's try this. Okay, can you see that?
Yes, we do.
Perfect. Okay, so this is sort of why it is such a contentious project. So in 1991, this yellow shaded area here is the range of the prairie chickens in Wisconsin. 10 years later, in 2001, we can see how much of that range has been lost. And then fast forward to 2023, the prairie chickens are pretty much concentrated to this small reddish brown area right here. So we've got the Paul Olson Wildlife Area, Buena Vista, and Leola, I think that's how you say it. But yeah, the Buena Vista Wildlife Area is a pretty substantial portion of the current range of prairie chickens. So you can see how much it has just declined in the past couple decades. So let's see, I'm gonna go back to, can you see the presentation now, or do I have to reshare that?
Reshare.
Okay, I'm going to then reshare a different PDF that I have here, just to provide some context. So the yellow and the orange highlighted areas on here are the proposed project. So it's the primary and the secondary array areas. And then the green shaded areas is the Buena Vista Wildlife Area. So you can see that it's very much like in and around the wildlife area. So several properties border the wildlife area, so a lot of residents in the area voice their concerns about the proximity of this project to the wildlife area. So
What's the existing use of the yellow shaded areas? Is it all cornfields, or is some of it wooded or potential habitat?
I think most of it is in egg production right now. I think it's in row crop. I think some is forested, and I guess that's a good question too, because the prairie chickens need like flat grassland type area, in my understanding. Again, stormwater engineer, so if I am wrong, please call me out on that. But they need flat grassland type habitat, and they don't do well with any sort of overhead structures either, which was an interesting thing that I learned through this process. So transmission lines, even trees, or other like structures that will impede their vertical line of sight, I guess, is not preferable for them. So very interesting. I honestly did not know much at all about prairie chickens until this project. So yeah, but all this area that is in shaded green here is managed as grassland, and suitable habitat for the prairie chicken is my understanding. So, and another part of the controversy too is that DNR does surveys for booming grounds for the prairie chicken, or I guess where the male prairie chickens will sort of congregate and do their dance, their ritual to try to attract mates. And those booming grounds are surveyed, and I'm pretty sure in the final order point for this project, there was some specific distance that the applicant agreed to be away from those booming grounds. So and they're also called LECs. Again, stormwater engineer. So if any of this is incorrect, please correct me. But I'm gonna go, let's see. I'm gonna go back to my normal presentation now. Sorry, this is clunky. Okay. Okay, so during the course of this review timeframe through the Public Service Commission review process, there was just an absolutely massive outpouring of public comments. So I was actually going through the docket yesterday, and they tally up how many comments they received, and 1,187 comments were received for this project, and the vast majority were from members of the public concerned about the prairie chicken habitat. So it just pretty amazing. A total outpouring of support, really. It's easy to say it's cool being from the stormwater perspective, because I'm not directly involved in any of this sort of threatened or endangered species portion of this, but it was really interesting to be a part of. And then another really interesting thing that I noticed is that typically when you've got different environmental advocacy groups that are coming together on a project, they're usually joining forces. But here it was very different. It was sort of like environmental group versus environmental group, depending on what their position was. If they were advocating very strongly for clean energy, or if they were arguing very strongly for threatened species conservation. So very interesting. And this last bullet point here was sort of the gist of a lot of the discussions we had. But what happens when environmentally friendly projects have the potential for unfriendly environmental consequences? So just a really interesting discussion to be a part of. It essentially boiled down to is a green project still green if there's these potentially significant impacts to a threatened species? So just a really interesting conversation to have that I don't think we always have that often. It's usually environmental advocacy groups that are coming together to advocate together. But yeah, it was just interesting food for thought, moving forward too, as we're seeing more renewable energy projects coming into our landscape, impacts and how do we manage those conversations, and do we have to shift how we look at it? I don't know, but it's really interesting to just think about too. And then in the final decision from the Public Service Commission, and this is a long process too, so I'm pretty sure the applicant filed with the Public Service Commission in August of 2023. And I think we just received this final order point in January of this year. So it's a very, very long process. But I just wanted to highlight these two screenshots that I took, specifically because they called out these individual array areas. So in the final order point, and there were many other aspects of the final decision. I think the final decision document is like 70 something pages. So this is just a very tiny part of it. But they did restrict where the applicant can construct to these, or to exclude these areas at the bottom. And I am very close to the end of my presentation. So let's see, I want to switch now to, I have some links on here that you guys will have access to in the PDF, but I have one to the final decision and then one to the docket. So I'm going to share the docket. So I think can you see that, or do I have to reshare?
I'm sure you'll have to reshare. Yeah, nothing's coming up.
Okay, perfect. I will do that. Let's see here. Okay, there we go. So this is a link to the overall docket for Vista Sands. And this is something that's available for all projects that go through the Public Service Commission review process. Very interesting. This is where all the information is kept. But the reason I wanted to throw this link in here is because those array areas that I mentioned and the specific numbers, you can go to this interactive map and just as a reference, see where they are in relation to roadways and creeks and the wildlife area. And you can see which ones the commission was referring to when they wanted to exclude certain areas, etc. So very interesting resource to go ahead and play around with. And then if you scroll to the bottom and you click on the access docket right here, it'll take you to all of the documents that were filed for this project. So you can see all 1,100 public comments, all of the applicant materials, hearing information, etc. So a huge, essentially database of information for every project that has to go through this review process. So I will leave it there.
I guess the big question to me is if that's 7,000 acres, it's probably going to be some number, 1,000 acres of impervious surface in the panels alone, plus any roads or driveways or anything like that, what kind of criteria are they going to have to meet for stormwater management?
Yeah. So we view solar as disconnected impervious, and we put out our solar guidance a couple years ago now. So the purpose of the solar guidance was to model a standard layout that we were typically seeing on a landscape, and to go through, do the modeling, figure out the criteria in terms of slope of the land, in terms of hydrologic soil group, and to put together a set of parameters where the applicant would not have to model that then. So if they put together, or if they constructed their solar project in accordance with the solar guidance, it's assumed that it would meet our performance standards based on how we did our own modeling for it. So I have not received any stormwater NOI documents yet. They have not come in for permitting yet. So I'm not sure exactly how that is going to look yet. But if they do follow the guidance, then it'll be assumed that the performance standards can be met. And that takes into consideration aisle spacing. And a huge thing too is the post-construction BMP, which for solar is vegetation. And in this area of the state, it's very sandy. Thankfully for stormwater construction, that makes my life a lot easier. It's very conducive to infiltration. So I'm keeping my fingers crossed that when I get the application materials, that infiltration likely won't be an issue. But yeah, there's a lot of different practices that we can work with them on, sort of like a mix and match of BMPs to make sure that our performance standards are met, and a lot of different resources that we can pull together to make sure that happens.
If it's basically comes down to vegetation, I assume that's primarily native vegetation.
Yeah.
Do they have to record or like a deed restriction that prescribes a certain maintenance regime, a maintenance plan?
Yeah. So, we have a maintenance agreement as part of the stormwater permit that they will receive through DNR. But on top of that, the benefit of these projects going through Public Service Commission is that that's also memorialized in order points through the PSC. So there's this additional level of, I guess, oversight or regulation that holds their feet to the fire, essentially, saying that they have to stick to what is in their plan. And for these big projects, it's deep-rooted native prairie plantings. And we have a seed mix expert who works with applicants very closely to configure, the appropriate seed mixes to use depending on the area of the state that the project is going to be implemented. So yeah, we have a couple different methods of ensuring that does get implemented as.
Great. See, there's a question from the audience. Do you know if they're going to install white or black panels?
No, I do not know that. The ones we've been seeing though, are the standard black panels. I don't know what the white panels are. I don't know if I've seen those.
Me neither. I have rooftop solar and it's all black, so. Another question, are there any concerns with transport of the bird virus and attracting waterfowl with stormwater BMPs and specific vegetation?
Ooh, interesting. We have not talked about the avian flu in regards to this project. And in terms of BMPs, so for waterfowl, Typically for these kinds of projects, the BMPs that are going to attract waterfowl are going to be your sediment basins during construction. But post-construction, we usually don't see very many basins be converted to permanent stormwater features. So I'm not sure what the applicant will be proposing for this project. I know in this part of the state, when there are sediment basins proposed, sometimes it can be hard to get water to stay in these basins when you've got such sandy soils. So I'm not really sure how much of an issue that's going to be here versus other parts of the state where you have more clay soils. But yeah, that's a really interesting
I
question.
think you're absolutely right on that.
Yeah.
What we permitted one solar project a couple years ago, and it wasn't big. I forget the exact acreage, but it was probably 8 acres, something like that. And they basically graded the entire site. I mean, even though they're basically just putting in posts and cables and stuff like that, it was almost 100% disturbance. Has there been any discussion about, if there's ways to work with the developers to reduce the amount of land disturbance? Because 7,000 acres of disturbance would be colossal. I would think if anything would impact the prairie chickens, it'd probably be more the construction than the panels themselves.
Yeah, that's a great question. So when I started in this role, it was about 4 years ago, about when solar was really starting to take off. So I learned, very quickly, right alongside the developers, what works, what doesn't, what can we do for the next projects. And through a lot of trial and error and lessons learned, we started requesting phasing plans. Because when you go into the winter months with, say, 300 acres of bare soil, it is a nightmare in the spring, or in January when we get rainfall events on frozen ground. You can't manage that. Sediment basins weren't designed to deal with that. So we've been having a lot of very specific conversations about how can we phase construction to limit disturbance. And in areas where you can't limit that disturbance, make sure your BMPs are designed appropriately. Like over design them too if you have to, because it's not worth the offsite discharge. But one thing that we have been seeing that is pretty consistent and kind of the norm now is when these developers come in, they will plant a cover crop before they even start developing. So they are starting with a stabilized work surface right off the bat. So it's, they're kind of starting off with it being in their best interest to not disturb more than they have to, because they already have that ground cover established. So they'd, essentially be creating more work for themselves if they disturb more than they have to. So that's been something that's been really effective at managing erosion and sediment from these construction sites, is the cover crop.
Can we book you to come back in 2 years and tell us how it all turned out?
Oh man, yes. Yeah, if they're under construction 2 years, I don't know. I thought I was going to have a stormwater application by now, but I'm not sure when I'm going to have it. It's being worked on. But yeah, I think this is going to be one that's under construction for quite a long time. So
Great.
yeah.
Well, thanks very much for coming to talk to us. Really appreciate it.
Thank you for having me. And any questions too, feel free to send me an email or reach out.
Will do. Okay, thank you. Next on the docket is Rick Eilertson, who's going to talk about his experience with 15 years of stormwater planning, design, and implementation for the city of Pewaukee. Rick got his BS from UW-Madison in civil environmental engineering in 1993 and has worked in municipal engineering since 1990. Rick's early interest in community involvement in environmental issues began in 1972 when, as a child, he helped his parents create a recycling drop-off program through their church in the village of McWanago. So, Rick, welcome, and why don't you go ahead and take it away?
Great. Leif, are you seeing my slide?
Yes, we are.
Great. So I'll be talking about some projects that we worked on with the city of Pewaukee since actually 2010. First one's going to be the Emerald Acres flood mitigation project, and you can see in the the upper left corner of the slide is the south section of the a culvert that goes underneath the CP rail, right in the just south of the Emerald Acres neighborhood. There's a residential neighborhood to the north that had been experiencing flooding, getting worse over the years. So 2010, the city had asked us to start looking at this, and we had done a little bit of site investigation with city staff, looked at this railroad culvert that was basically constricting flow for this area. It was roughly a 5 foot wide by about a 5.5 foot tall concrete cast in place culvert. The south end was labeled 1902. The north end was labeled 1919. So I don't expect that it took 17 years to build this culvert. I think the north end was just an extension, a widening at some point, obviously in 1919. This is the bottom of the culvert, so it's an open bottom with land and stone in the base of it. Looked like it had been hand placed, obviously over 100 years ago. And this is the just during construction what the ultimate solution ended up being for providing drainage. A couple of the topics that I'll be covering is just the flood risks that were contributing to the need for the project, a number of the project hurdles. So talking about the railroad permits that we needed to get, Wisconsin DNR and Army Corps of Engineers permit applications that needed to be submitted, and then all the work was done on private property on land that the city didn't have ownership of or even easements of, and so there's quite a lot of hurdles for just getting private property owner permission, as well as the railroad, which was just obviously pretty challenging. And then a few different keys for successfully installing casing pipes and culverts under an active railroad and through wetlands and waterways on private property. So this is the watershed draining to this culvert, about 263 acres that predominantly residential. There were a few different stormwater facilities that have been installed historically, and then just prior to, somewhere in the 2010, 2011 timeframe, another pond had been enlarged right here north of the flooding. The bulk of the flooding area was along Emerald Lane, and this little residential subdivision right here. Railroad culvert, this is the CP rail line that well over 100 years old, obviously, that had been constricting flow. And then water continues draining down to the south. Some photos that the city had provided for flooding that was happening 2010, and then a number of years later, 2017. Obviously, this there was a lot of concerns that residents in the area had, as well as some roadway overtopping that was a concern. So in 2012, we were able to finish up a report that helped identify some different options for improvements, and then we started working on did some soil investigation. At that time, we were actually able to get permits from the railroad to do some soil borings right on in the railroad track vicinity. which is pretty interesting. You got a special rig for actually doing borings on the rail line itself. One of the things that, because this is a wetland and it was designated as a waterway, when the city of Pewaukee was a town, when this particular commercial development went in, they put in a 54-inch culvert, and one of the concerns that DNR had is prior to this, the water flowed through where the building is now. And the initial DNR staff person that was reviewing this was concerned that they felt this was an enclosure of the waterway, and so there is a need to do practical alternatives analysis that the city staff and AECOM helped work together on. So the DNR had asked to look at options for basically removing the enclosure and pulling, basically putting a new drainage way where the 54-inch pipe was downstream. So this is one of the alternatives. Another alternative was to keep the 54-inch pipe here and then relocate a drainage way around here. And then another one is just a slightly different configuration of a similar, just different grading of a similar swale. In all of these, we looked at initially we had looked at two culverts and leaving the existing culvert. The city's position was that this was a railroad-owned culvert, and then the railroad decided they really didn't want to keep it in place. They wanted the design to include the ability to eliminate this existing culvert because of structural concerns over it. So that added a third 72-inch diameter casing pipe with a 60-inch diameter pipe inside of it. The railroad also wanted to be able to have the flexibility to add a third rail at some point in the future. So that ended up requiring the extension of putting a railroad bridge or basically a retaining wall farther out than what the city would have liked to do originally. So that ended up modifying the existing waterway even further. So a couple of different concerns for the project. Obviously, doing this under active rail line working, there was special flagging that needed to happen during the project. The contractor ended up being Lender Construction, and they had some really specialized equipment that they do a lot of work on rail lines that ended up really helping to save the project and get it done in a timely fashion. But DNR was, rightly very concerned about this. There's obviously fiber optics that we had to be concerned with, making sure that we were clearing those when the casing pipes were being installed, and then also just making sure that the stability wasn't creating failures for the active rail. Initially, we had looked at like the red limits show basically the footing of a concrete retaining wall, and this concrete retaining wall with the concrete footing was started before I had the opportunity to work on the project, and when we went into bidding, we told the contractor we'd be open to looking at a steel sheet pile retaining wall that would just need to be that could be done potentially done by a change order, and we realized that the limits where the retaining walls or the footing was would have really created some significant structural problems with the existing rail line. And one of the things that Lunda was able to provide during construction is an alternative of basically putting sheet pile retaining wall in, which ultimately ended up being a really good solution. Our structural engineers worked with Lunda on this and ended up saving quite a lot of money ultimately. That was a big success. And I think probably one of the keys going forward, or at least key learning lessons that I had, is to work with a contractor that's done these types of projects prior to design. I think we could have saved a fair amount of time and some design money as well as construction money with not having to conduct the change order. The railroad was really concerned about the settlement monitoring, so we had to have a registered land surveyor survey multiple times per day at multiple locations. So these show all of the different subsurface and below grade monitoring locations that we needed to do throughout the duration of the project, just to verify that we didn't have undue settlement. And then obviously had to have contingency plans for notifying the railroad if there was anything that was being adjusted by more than 3/100ths of a foot. Again, some really specialized equipment that help make the project run much more smoothly. I had never seen any equipment like this before, so it was pretty cool to be able to witness that in action. Here's the casing pipe, basically the boring and jacking rig setup. So they had just put the eastern 72-inch diameter casing pipe in, and they were in the process of boring and jacking the middle culvert pipe. One of the issues with casing pipes is you have a lot of control over exactly where you start. You don't have as much control on where it ends up. All of the pipes were started from the south side going to the north, and I think the first one the pipe went up about 6 inches more than we wanted to. The second one basically went down about 2 inches. There's still pitch on it, but not as much pitch as we had hoped. So it was about 2 inches lower than what we had desired, but not too terrible. And then the other one actually went down about 4 inches below what we wanted to, and there was actually back pitch on the pipe itself. We were able to make some adjustments because we had a little bit of wiggle room with the 60-inch pipes interior in that of the pipes before they were grouted. So we were able to make up some of that, but we weren't quite where we would have ideally liked to be. We were able to rerun the XP swim calculations, and it still bore out that there weren't that we still were having the capacity that we needed with this ultimate solution. So some of the different challenges were the bank stability, and because we had so much construction going on around the existing culvert, we really tried to keep the equipment off of that as much as possible. Again, continuing to do the monitoring multiple times per day was definitely a challenge. Here's some just pictures showing the welding as they're pushing those pipes through and getting it to the opening. So this is on the north end, and they basically were able to keep pushing it through, and then also one of the interesting things was they used the pipe itself to tie back to the steel sheet pile retaining wall, which was something that our structural engineers hadn't really thought of during the design, and some just really unique um, benefits to how Landa was able to help our structural engineers come up with cost-effective solutions for building this. And this is the pushing the 60-inch plastic pipes through the high-density polyethylene, and then the grout that the contractor used to fill in that annular space between the plastic pipe and the steel pipe. Some of the challenges were just maintaining flow through the existing culvert until we are ready to open up the new culverts. You can see right now we're basically forcing flow around to this is on the north side. Flow's coming from the east and then going south into the culvert. Here's just another view of that upstream side coming right around the steel sheet piling wall and then going into the existing culvert right here. And this is where it's coming out of that existing culvert and going downstream. So they had quite a lot of steel sheet piling as well as some temporary rock-filled bags or soil-filled bags that they had for serving as a temporary barrier. And then this is the final cleanup just before, or just on the left side is just before flow was introduced to the new culverts, and then ultimately the railroad decided to fill the existing culvert, so they contracted directly with Lunda to be able to do that, and were able to issue themselves permits in a day as opposed to taking years for us to get permits for work that the city wanted to do. So that's that project. I'll jump into the next project is the Catherine Courts Drainage Improvements Project that we started in 2021 or 2020 actually. As a study, the city had been getting concerns from residents on the Foxwood Court area here about constant flooding, and this has been happening for decades apparently. When this little residential subdivision went in, blocking flow that was on private property, a private commercial property up here, and basically the limits in red were the limits of ponding or flooding, that there's just no drainage, there wasn't positive drainage, so water would have to pond up here about 3.5 feet deep before it would go out into a concrete flume that was built as part of this residential project in the late 80s. But there's about 275 acres that drain through here that we were able to model, and then the city had asked us to come up with at least 3 solutions or alternatives to help resolve or reduce the flooding concerns through this area. Here's the layout of this little residential subdivision. I believe it's from 1987. What you can't see, you can see the proposed contours. It's a little bit tougher unless you zoom in to see what the existing contours were. But this basically was filled up like 5 feet to build the public street and the private homes through this area. And then they did allow for drainage going through, but this is about 3 feet higher than what the original existing grade was. And so that was clearly something that the designer and the reviewer didn't catch when this was prior to this being built, which obviously led to the ponding to the west here on private commercial property. So this is that red area you can see that's the limits of the ponding. First alternative was to put a low flow pipe through here, relatively deep, and then run it down here to a drop inlet structure. One of the things that we had massaged with the design was the possibility to utilize this as stormwater treatment. So basically looked at this option included a perforated pipe and putting in engineered soils in this area, and then draining that pipe into the existing storm sewer in Springdale Road, right at the divide between City of Pewaukee and Brookfield. So that alternative came in at this cost, at this approximate cost for a preliminary design. The next alternative was to utilize an existing 20-foot wide drainage easement that ran through the south end of the development. Unfortunately, there was old growth trees that were in here. There's not positive drainage through this, what they identified or what was granted as a drainage easement. I suspect that the thought was that the drainage easement would go both ways, and that's basically what the lay of the land had. But residents had built sheds and other equipment over top of the easement limits. Obviously, all is an old tree line, and so this likely would have needed to be directional drilled, for the amount of existing drainage easement width that we had. Costs obviously were much more expensive to do this shorter length of pipe, but certainly would have been really very challenging to construct, and obviously all on private property. Within the existing drainage easement, likely would have needed to get a much larger temporary construction easement and maybe even a larger permanent construction easement. But the costs and those issues kind of made that alternative not too desirable. Another option was to basically use this existing route on the north to drain down through and basically replace. There's a concrete flume that ran through this area. Would need to replace it down with a regraded ditch that had positive flow, which would have been very challenging. The regraded ditch would be a 0.09% slope. With anybody that's designed vegetated ditches knows that that's basically impossible to get decent drainage for. So it would have been just a flat, pretty much a flat waterway that would have been really challenging to get to work desirably, and a little bit higher construction costs. These are some pictures prior to construction. That flooded area, this just happened to be dry during this time period. This was ponding for periods of months before it would dry up, and still ponds today, but not generally it's a period of days to weeks as opposed to multiple months. So the concrete drainage way, concrete flume that runs through that outlet on the north end. You can see some residents have been utilizing the outlet for gardens, for burial plots, I assume for pets. Here's the layout that shows the ultimate solution. After we did the topographic design, we realized there's an existing water main through here, and the grades we needed to actually cross through the water main and get over onto the Springdale Road side of the existing storm sewer to get positive drainage through here. So put a solid PVC or HDPE pipe to about here, and then perforated the rest of the way, and then design this as a bioretention area. Some construction photos. This is the water main replacement that we needed to lower the water main in order to get underneath it at the grade we needed to be. There is an existing culvert that had been bypassed there had been flow had come around it, so we replaced that culvert to restore basically the original stormwater management feature for the area. Put a bentonite clay collar in there to reduce the chance of seepage. One of the things that we had talked about prior to construction is, should we do soil borings? Ultimately, we made the bad choice to not do soil borings and found the rock during construction. For a couple hundred feet, they were able to dig it, with basically jackhammering it and rock teeth with a bucket. Ended up, it was going so slow, they just realized they're not going to be able to get the rest of it. Rock was getting deeper and more competent as they were going along. So we had to take a break, do some investigation, and then look at coordinated a change order to do blasting, to do rock blasting for the rest of the rock limits. So that we lost a couple months just from doing that. It was really, this is after it was leveled out, but portions of this area that were blasted were like 5, 6 feet higher than what the original grade was. It was literally like a bomb went off, because effectively that's what happened. But this is after they leveled that material out, and so there's a lot of excess material that needed to be removed from the site to basically get back to the original grade. Here is just a photo of them digging through that blasted rock to put the storm pipe in. This is that far upstream end. This is the drop inlet structure. So we place this about a foot above the existing area, so that basically forced ponding about a foot before water would go into the storm system, and then had engineered soil in through the rest of this to allow water to drain down through and then serve as effectively as a biofilter, to basically get treatment on that 250 acres that was upstream of this portion of the watershed. This is just after construction, during placing of the erosion mat. And then this is just farther upstream, or farther downstream, sorry, with seeding and erosion mat placed. Some pretty interesting equipment that was able to be utilized on this project as well. This is September, so we're getting right towards the end of the growing season. And then this is I guess a little bit later in September after a big rainfall. You can see the water's up to about a foot ponding here and going into the beehive grate structure. And this is a couple weeks later. There's a couple of different rains in here, so it's still obviously wet, but not significant standing water 2 weeks afterwards. I think with that, I'm going to stop. And if I don't know, Leif, if there is time for questions, but my contact information is here if anybody wants to get in touch with me after the fact.
We ran a little long, so I'll just ask one question, Rick. So with the foundation sheet piling structure for the railroad, you suggested that because it was such a specialized thing that you would have been better off if you'd basically run it by the contractor first or gotten their thoughts on it. How, just from a procedural standpoint, how would you do that? Because they're also going to be one of the bidders on it, presumably. So would you do a separate RFP just asking for design help, and then you take that, put it in the plans, and then bid that out?
I think so. I mean, you can, there's consultation that you can do sometimes with contractors prior to design, just to get to get thoughts out there. I think logistically, now if I would have been involved with it to begin with, that's probably something that I would have looked at doing initially, because the concrete footing just wasn't, in my opinion, it wasn't constructible. As far as, we just wouldn't have, there was no way to keep that existing rail active. But a lot of times, you can solicit, just contractor consultation during design without, at least I haven't had issues with that in the past.
Okay. Well, those are some really interesting projects. Thanks for sharing them.
Yeah.
Okay. All right. Last and hopefully not least, we're going to talk about some water quality trading for MS4 compliance. And I'm going to talk a little bit about what Waukesha County is doing, but first, Maureen McBroom and Patricia Cicero are going to talk about what the city of Watertown and Jefferson County are doing. Patricia is the director of the Jefferson County Land and Water Conservation Department. Prior to this position, she served as the Water Resources Management Specialist for the same department. Patricia holds a Master of Science degree in Water Resources Management from UW-Madison and a Bachelor of Arts degree in Math from Kenyon College. And Maureen is the Stormwater Project Manager of the City of Watertown's Engineering Division. Prior to this, Maureen worked for the DNR and then for Rupert and Milky. She kicked off her career in water resources at Jefferson County Land and Water Conservation. Maureen holds a BS in Environmental Science from Carroll College. So why don't the two of you go ahead and do your thing, and then I will finish up.
Hi, Leif. Can you hear us?
Yes, we can hear you.
All right. Do you see our presentation?
Yeah, we can see it. It looks like you're in like the presenter mode, maybe,
Oh, you don't want to see that.
where the next slide is also showing up.
Well, we don't want to give you a heads up beforehand. So how's that? Is
There
that
you
any
go.
better?
That's it.
All right. All right. So thanks, everyone. As Leif said, that we're going to talk about the Watertown Waterways Improvement Program. So this is the local water quality trading program that was developed between the City of Watertown and Jefferson County. So
yeah, and Patricia Cicero here, co-presenting with Maureen. Is it?
So we are working on moving slides. Let's get our next slide.
All right.
All right, a little bit of background on the City of Watertown's MS4 permit. So we are under the general permit, which means we've had MS4 permit since about 2006. And the Rockford TMDL came out about 2011. So after that, there was a significant planning process that went on with a lot of the MS4s within the Rock Basin. And Watertown determined in 2014 that really your traditional urban stormwater practices were not going to cut it. So we had a plan that was under development back then that was costing about $13 million to implement in 2014 dollars. And that wasn't even going to get us to the full compliance with the phosphorus reductions. So basically at that point, we knew we were going to need something different, like a water quality trading program to meet the TMDL requirements. So fast forward, things had to happen internally to set us up to the point where we could start looking at water quality trading, budgets and hiring a stormwater project manager, starting to look at things like consultant-led water quality trading, or using the clearinghouse, or doing this internally. At which point we decided that these probably were not our best options. And we started talking with Patricia at Jefferson County.
So this is a slide, go over briefly, that explains the work that the Land and Water Conservation departments do in counties. We implement a lot of practices on the ground, mostly with agricultural producers. And so we work on planning for projects, implementing them, helping them get funded and in the ground and being maintained properly. We do also implement a farmland preservation program where farmers are required to follow a number of state standards. I include this because a lot of times we've been talking to MS4 communities, and we always get the question about, well, what kind of standards do farmers have to follow? So basically, once Maureen and I started talking, we did decide that, okay, it looks like it would be good to have a partnership between the county and the city to work on water quality trading, mostly because the city didn't have expertise working in farmland areas, and the county does have that expertise. We have existing relationships with the agricultural community. And right around this time for our office, we were restructuring a little bit and had a position that we could make sure that they could work on this project. So the timing was very good in that aspect. And then one of the steps, just to let people know, is that we did do an intergovernmental agreement between the county and the city, which basically, I won't go through this slide, but the county is responsible for the technical aspects of getting the practices on the ground, where the city had a number of responsibilities, mostly relating to their permit and communications with the DNR.
So you're probably getting a sense that there was a lot going on to develop this program. And as opposed to a one-off trade to meet some permit conditions, this is a multi-decade program that we set up. We're anticipating a couple dozen projects at least to be implemented under this program. And we did have partners. So the Rock River Coalition really helped out with the outreach, the marketing, pulling together the landowner meeting that we had to kick off the program in August 2023. They do have information about this project housed on their website. So our rockrivercoalition.org will be the place to go to find the water quality trading program that we've done. I will say that Patricia's whole staff was critical to making this whole program work. Our staff here in the engineering division were all involved in trying to work through all the details. And in addition to that, we also had our city attorney involved. We had our city finance director involved. We were doing a lot of education ourselves on the city end with our elected officials and going to Public Works Commission and also going to take resolutions to Common Council. So there was a lot of moving pieces in this. I'll say DNR also was a partner in this, in that they had a lot of information and a varied responses to our different questions. Setting up a water quality trading program to meet the MS4 permit was a little different than setting it up for a wastewater permit. So there were multiple meetings, conversations, yada, yada, yada. One more button. Okay.
So also in the background, our office did a lot of work trying to figure out maybe what some of the highlighted practices that we could come out with and talk to the landowners about. So these are the practices that we selected, and we also figured out installation rates based on our knowledge of what other counties are doing with these types of practices, and also had in some practices an annual payment for the length of the contract, which we decided to go with 10 years. So these are the practices we highlight. Certainly if there's a practice that a farmer needs that would also align with the needs of the city, we would also look into those practices.
All right, so some of that budgeting that I alluded to had to do with the annual budgets for the city, for the county, for Rock River Coalition, all coming in. Of course, being a city, we're working on our budgets for the next calendar year, starting about July or August, right? So we're all trying to get our estimates together. We have completed one practice so far. trying to estimate what it's going to take to go into that practice versus what it took to get into the whole program development was a little challenging, but we did it. So the city is paying for the county's staff time, vehicle use, printing, postage, office supplies, etc. And you'll see the county charges for 2023 and 2024 on your screen. So we're anticipating hopefully those costs going down just a little bit for 2025, because now we're focused more so on practice installation as opposed to the entire program development. The first practice installation cost that we reimbursed to the property owner was almost $2,300, whereas the first installment on the 10-year plan was the $4,040. So overall, the entire 10 years, we're talking about $45,000 for this one practice, which comes out to about $58.26 per pound of phosphorus, not including our consultant fees. So how to calculate that has been a little bit of back and forth, but we're just focused on the actual practice with those per pound prices you'll see there.
So like Maureen said, we completed our first practice last year, and it would involve 2 harvestable buffers on one landowner's property. And we felt that this was a great practice because for farmers that have livestock, they still have use of that buffer, that vegetated buffer, by harvesting it and having some feed for their livestock. So the landowner signs an agreement with the city of Watertown for the 10-year timeframe of the project, with an option in the future to renew that under a new contract in the future. So the vegetative buffers were installed. DNR did review the work that we did and conditionally approved the practice. And we completed the public notice process. So the next step is when the MS4 permit comes up, again for renewal, that trade will be listed in that permit. We did modeling of the practice with the SNAP Plus modeling, which is a program that counties are very familiar with for nutrient management planning. So that's how the phosphorus amounts were determined. And we're starting to plan for the second practice, and Maureen did some number crunching, and based on the first practice, maybe around 24 more practices are needed, but that can change depending on the practice and the land that we install it on. So I got ahead of myself to talk about the SNAP Plus modeling. The trade ratio that we determined, again, with a lot of conversations with the Department of Natural Resources, ended up being a 2-to-1 trade. And you can see that the amount of phosphorus that's reduced each year in the total suspended solids. There's an option as to whether to claim the interim credits, and for this first practice, the city decided to do that. We'll probably have discussions about that in the future as we continue on with more practices.
So just to wrap it up, there are some lessons learned or insights that we came away with. The relationships were key. So knowing whose role was what and really whose strength was what was huge. So as Patricia mentioned, the city engineering staff knew that our expertise were not in using SNAP Plus and doing agricultural modeling. So that was beneficial for us to know that we need to rely on the county staff, and they had expertise to do that. So it was a win-win there. Those regular communications with DNR, I don't think we would have gotten this far without having that. So we do appreciate that. Having the Rock River Coalition on board to help with the outreach also was huge. Maintaining the relationships with our elected officials and making sure that they understood why we were doing this and what the alternatives were and why this was the best solution was huge. So I think I'll just kind of stop at that point, because Leif, I know you've got some pretty interesting stuff to get into also. And this is the fastest we've ever done this presentation. So Leif, I hope we did okay.
Great, thank you. Well, let me see if I can share my screen here. There we go. Okay. The Waukesha County is also doing water quality training for our TMDL compliance program, but ours is a little different from what Watertown is doing because theirs is mostly agriculturally based. We checked into doing it, as I'll hopefully cover here in a minute, but we just could not find any agricultural partners. So the Waukesha County right now includes the Rock River TMDL in the northwest corner of the county, like Maureen was talking about. We also have the Milwaukee River TMDL in the northeast corner of the county, and the Fox River TMDL is in the works for the kind of the center south part of the county. The county MS4 in the Milwaukee River watershed is entirely highways. We do not own any parks. We do not own any other land. It's just all highways. So within that TMDL area, at least in my screen, I'm not sure if you can see it, but it's might be covered up in the whatever view you have. But in on the right edge of the screen, it should be showing the 8 sub-watershed or the 8 reach sheds that form the TMDL within the county boundaries. The county has MS4 or highways in 7 of those reach sheds, and we have a TSS and total phosphorus treatment shortfall in all 7 of them. In most cases, not a very big shortfall, but still one that's a struggle to make up. So we looked at every BMP we could think of to come up with a compliance plan. We looked at street sweeping, we looked at building basins, we looked at acquiring property, we looked at trying to do things within the right of way. And obviously we looked at how effective they would be, we looked at what the cost would be, we looked at whether they were actually feasible to do or install, and we looked at inventoried all available locations. Some of the issues we ran into were that street sweeping is, generally feasible, but if you look at, what the SLAM results are for it, it's fairly limited in what you can get. In most cases, it's hard to get more than, say, 10 or 15% pollutant removal with sweeping, if that. And the more you do, the rate of return diminishes. And although a lot of our highway system in that TMDL is curb and gutter, there's still some that's a rural cross section, in which case we can't do sweeping. You have to have a curb to sweep. Another issue is that our highways generally have a discharge point about every quarter mile or so. And the network of highways in that in the TMDL watershed totals about 20 miles. So we have something like 80 different discharge points. So if we had to build a basin at a significant number of those, we could be building dozens and dozens of basins. It would cost a fortune. The watershed's pretty built out, so there's almost no available land for BMP and construction. And the county admin said that we weren't going to purchase land anyways, partly because of the cost, partly because they don't want to get involved in eminent domain or anything like that. So in 3 of the reach sheds, we were able to demonstrate compliance by bumping up our street sweeping and doing some BMP improvements in the right-of-way itself. But in 4 of the reach sheds, we had to look for some other way to comply. So we read through the 2020 water quality trading guidance to look for ideas. Initially, we thought ag trading sounded like the way to go, but there's no ag land left in that part of Waukesha County. But the watersheds do extend a ways into Washington County. So we looked around there. We touched base with our counterparts at Washington County to see if they knew of any candidates. And we did find a couple of farmers that we approached, but they were not interested. And all the other properties just didn't work for one reason or another. So we realized that stream bank stabilization might be a possibility, read through Appendix F of the guidance. We did an inventory of all the reach sheds using GIS and field surveys and located at least one section of stream bank in each of the 4 reach sheds that were where we had shortfalls that showed measurable bank erosion through a comparison of historic air photos. We didn't have time to do the thing where you pound rebar into the bank and then come back a year later to see how much of it has gotten exposed. But we did have pretty good quality air photos going back to the early 2000s. So we were able to do comparisons over a 15 to 20 year time span. And that's how we came up with our regression rates. Another criterion was we were just looking at land that was located on accessible municipally owned property. We didn't look at private property in part just because we felt that would complicate the access and permissions issue. So we just looked at municipally owned land. Unfortunately, there is a significant amount of parkland and other land that's owned by the different municipalities along the Menominee River and Underwood Creek. One thing that was brought up was that the guidance said that MS4 conveyances are not eligible for stabilization credit per the guidance, but we got some clarification on that, and our understanding is that that refers to ditches and pipes and gullies and so on that were specifically built to convey runoff, and it does not apply to natural creeks and rivers. So after locating these locations, we generated cost estimates to find out what we thought it would cost. The county does not have, counties by statute are not allowed to create utility districts. So we did not have any money. And then ARPA came along and some funding fell in our laps. Like it was like manna from heaven. So we reached out to 4 potential municipal partners, in this case, Menominee Falls, Brookfield, Elm Grove, and the Village of Butler, and made an offer where we said, we will pay for these projects, manage the projects, if you'll give us access, and what they'll get out of it is we would share the load reductions. And they all agreed. So we signed agreements, we submitted NOIs for trading, we did soil sampling, preliminary field work, some surveys of the banks. We updated our TMDL compliance plan. We produced water quality trading plans and submitted them to the DNR. They were approved by DNR and they're currently in the public comment phase. We hired a design consultant. We started the waterway and wetland permitting process with DNR and the Army Corps of Engineers. We worked through the municipal permitting, did a couple of rounds of design updates based on DNR feedback. We bid out the construction of all 6 projects, the 4 stream bank projects and our 2 highway projects as a bundle to make it easier to work with a single contractor. And construction starting this month. We've already started some of the tree removal in order to meet the long-eared bat deadline. So like I said before, we use air photos to assess bank erosion rates. The plans are mostly for boulder toe stabilization with the banks slope back to create additional storage, make them more stable. They'll all be revegetated with a mixture of like low grow, no mow mixes, native seed mixes, native vegetated mat. We're doing live stakes in one location, and we're planting some trees and shrubs in others. One of the projects is using some tow wood. There's a requirement for the Chapter 30 permits to reuse some of the trees that are taken down on sites where there is some tree removal. So we're using that to also meet the habitat credit. Another way on sites where we don't have trees to repurpose that we're going to meet the credit is using rock wing deflectors, where in the detail on the lower right corner, you can see the black wedges are the rock wing deflectors. Those are intended to create riffles, direct water more to the foul weg in the middle of the stream. We initially had aimed to use more tow-wood, but we either lack the trees to reuse on a couple of the sites, or else extremely steep banks and relatively low water base water levels made that difficult to do. On two of the sites, we incorporated some access steps to make them amenities to the parks. Each of the projects is being constructed on one side of the stream only, mainly for accessibility reasons. So what we're doing to prevent erosion bounce back on the opposite bank is to plant them with trees and shrubs. So between the four projects, the total stream bank length is about 1,000 feet. The total construction bid was about $500,000, so that works out to about $500 per foot. Design was about $80,000. Reductions before uncertainty factor and sharing, so which uncertainty factor divides the reduction by 2, and we're splitting it. So again, the county and our partner communities are getting roughly 1/4 of what I'm showing here, but the 5-year TSS reduction is about 70,000 pounds, which works out to about $8 a pound. The 5-year total phosphorus reduction is about 75 pounds, which works out to about $8,000 a pound. These numbers I just put them down really quick, so please treat them as back of the envelope. I guess that's my last slide. So if you have any questions or comments, now is the time. I see we're just after noon, so I'm not seeing any questions in the chat. Maureen and Patricia, did you have anything else you wanted to add before we say goodbye?
No, thanks for inviting us.
And
Okay.
if anyone has any questions, feel free to reach out to us.
Sure. All right, so I guess we're going to call it an end to our workshop then. Just a reminder, you'll get an email evaluation form from Wisconsin Land and Water. We value those very much, so please complete them. And once we get your evaluation, we'll send you PDHs if you want them. I'd like to thank all the presenters that took the time to put these great presentations together and then show up for our workshop. So I really appreciate what they do. Also like to thank Kelly and Wisconsin Land and Water for making this happen from a technical standpoint. We did have some issue. We send out the invites, as the poll noted earlier, by email. The county sent out emails. Wisconsin Land and Water sent out emails. Wisconsin Land and Water also sent out the registration notice. We know that some people didn't get them. So what I'd suggest is that our workshop will likely be in April again next year. So I would suggest that you put a note on your calendar at, say, the end of February or beginning of March, where if you haven't heard something from us, why don't you reach out and just ask for an update. So I guess with that, I will say goodbye. So thank you very much for attending.